All right, guys, welcome to the second code marathon. It's been a while. Today we're going to be doing something a little bit different. I have nothing prepared, so I'm going to explain it as I go. I want to do a parametric mug. This is a mug that I actually built out of ceramic in high school a long time ago. I don't have the original thing anymore, but it's a design that I was going to model in CAD, and then I figured it's really just made of two or three basic shapes that would be kind of interesting to see if we could model it parametrically in Babylon specifically, um, so that we don't need to use CAD if we didn't want to. I pretty much try and avoid using CAD as much as possible, and I try and do as much as I can programmatically in tools like Babylon with JavaScript or TypeScript. So let's start by creating a cylinder. I like to keep these calipers next to me just because it's a good reminder to see like how big of a thing you're actually working with. In this case, I think a nice opening for a mug. Maybe we could use this bottle as like a reference. Oh fuck. Um, that was dumb. I think a good opening for a mug is like 60 millimeters, or a good outer diameter. And then in terms of wall thickness, maybe like 4 millimeters, just to keep nice round numbers going for us. I like to kind of use the offset tool even when it's not really necessary. We could just draw like a smaller circle within this, but damn, 4 is looking a little bit thick on the sketch, but looking at it in real life, that kind of looks like about what you would expect the wall of a mug to be, so I'll leave it. Yeah, I think the offset tool is nice because if we wanted to parametrically change that later, we could. Okay. Another probably better way to do this would have been with the shell tool, because that will also just create the bottom for us automatically. So I think I'll probably do that. 60. In terms of height, probably want it to be, again, this is going to be parametric later, but just to give you guys a good idea of what this mug is going to look like as like a nice form for it, or a nice general set of parameters for it, maybe 110 millimeters tall. And then we'll go ahead and use the shell tool on this. And we'll do like a 4 millimeter wall. Yeah, that looks pretty good. Let's hide that sketch just because it's kind of throwing me off. Okay, so that's like the main body of the mug, and then the handles of the mug are actually held on with trapezoids. That was sort of like one of the main design, unique designs of this mug. So let's draw those right now. I think I'll probably just use lines to do it. And then we can come out maybe 20 millimeters. And we will mirror this. Make that tangent, make that hit the intersect with the circle. We can add a constraint too, like intersection constraint, I think. Yeah, like a coincident constraint. I think we could make sure that that's always intersecting the circle, but it's probably not worth it just to demonstrate this model to you guys. And then for like a trapezoid, I kind of wanted it to have a flat face. So maybe we'll have it come out. I'm just eyeballing these things, these numbers right now, 12. But I think modeling it is going to help us get a feel for, yeah, 12 is definitely not enough because when you're holding a mug, you need clearance for your hands between your hand and the handle. So like the handle should probably be at least 35 millimeters off of the wall of the mug. We can change this to 35. And then there's actually going to have to be clearance between the edge of the trapezoid and where the handle sits on the trapezoid. And that will probably need to be at least 8 millimeters. So we'll just add 8 to this. And then for like the shorter flat side of the trapezoid, if that is 20, maybe we should make it like half. So we'll do 10. And then we'll just draw a line connecting these two right here. And then we can mirror all of these lines. Perfect. And then we'll extrude that. Should probably have it match the wall thickness of the mug. I think that could be nice. But it's also looking a little bit thin when we do that. So maybe we'll bump it up to like 6. But again, these are all going to be parameters. So every number that we've kind of been questioning and plugging in is going to become a parameter in the final design when we do it. And then also let's just make sure that that extrusion was a new body operation because I don't really want it to connect to the other cylinder yet or ever really for this model. Let's move that up, maybe the clearance between the bottom of the mug and like where the handle joins, probably want at least like 20 millimeters. So yeah, that looks good. And all of these numbers that we're calling out, we're gonna have to remember not the specific numbers, but which part of the design we had to choose a number at because those are going to become all the parameters. And then we'll copy that, move it up. We probably want that spacing to be even. So if the mug was 110, this was 6 millimeters, right? So if the mug was 110, is that from the bottom? Yeah, I think that's from the bottom corner to the bottom corner of this top trapezoid. So it was 110. We want this to also be 20. So it would be 110 minus 20 minus 6. To the top and then minus 20 again. And that should get us 20, I think, at the top. That looks about right. So we'll roll with it. And then we'll measure this just to make sure that our math was right. Yeah, that looks good. Okay, cool. And then another thing that we forgot to actually put into the sketch was a circle here to accommodate the handle of the mug. Also, that 20 millimeter thing isn't looking right because if we measure the distance between these two surfaces, that's 58 millimeters. That's not really enough. That's only enough to stick like 3 of your fingers into. Oh, I just realized we forgot to start the code marathon timer. Let me do that. And our goal finish is going to be 3 hours this time. Okay. So we got a little bit of an unfair head start, but that's okay. So yeah, 58 millimeters is not enough. Like if I put my fist between these calipers, we're looking at 105 millimeters with like a decent amount of clearance, and I don't have huge hands, so that doesn't leave much room at all. I mean, that barely leaves any room. The cylinders would have to be, or these trapezoids would have to be right at the top. So let's go back and actually change the amount that we move this by. Let's move this down to 10, and then that was referenced off of that one, so that's going to change. So we need to move this up by 20, and then we just added 20 millimeters. So that's still, I mean, that's still not really enough room. That's going to be 78 millimeters between these two surfaces, which is, yeah, that's like, you can't really even put your fist and get like a good grip on that handle. You kind of be doing like a 3-finger hook type thing. But we'll leave it for now just because I think that's why I wanted to do this parametrically, because we'll be able to just plug in all those numbers later and then change them as needed. But let's go back to that original sketch because we did forget to put a circle for the handle to go into. So let's let's make a line, and let's reference like I guess the handle should probably reference the end of the cylinder instead of the end of the trapezoid, even though it kind of makes, both could work. In this case, we probably want the diameter to be something like this Sharpie. Everything here is wet because I spilled water on it. So this is like about 12 millimeters. So if the whole thing is 43 and there's 6 millimeters, and we want like, and there's a 6 millimeter radius, and we want like 8 millimeters of clearance, we'll do 43 minus 6 minus 8. And then we'll do an 8 millimeter circle right here, and then that should give us like 8 millimeters of clearance from the edge of the trapezoid. And then we'll finish that sketch. Then we'll just reveal that sketch and we'll do like a cut extrusion, or we could modify the original. We could modify the original extrusion so that these are not part of the extrusion. I kind of like that, actually. It just seems easier. Okay. And then we want to extrude the actual cylinder that will form the handle. So we can kind of want to run a projection. I think the cylinder should run up to the top and be flush with that, and then it probably shouldn't go all the way to the bottom because that would make it difficult to put the mug down. So it should probably have a couple millimeters clearance and maybe go halfway between here and here. So I like to do a offset plane from here. We'll just do a 0 offset from the top, extend that plane out that way, and then I'm going to select this circle and project it onto where's the projection tool? Going to project that onto the plane. Projection tool is not. Okay, well it is. You have to press P. So I'll just select this geometry. Can I just project this? Yeah, I can. I can just project that onto that. And then now we should have the circle up there. Okay, cool. And that's going to be like a new sketch, which is fine. And then we'll extrude that down. We want it to be 5 millimeters. And we don't want it to join. We want that to be a separate body. So we'll have to come down negative 105, because that will leave us a 5 millimeter gap to the bottom. But then you get like an uneven extension or like protrusion of the handle off of those faces. So that kind of looks bad. I'll do an offset of 5 millimeters so that it's even, or a negative 5 millimeters rather. And then the overall length will only be 100 millimeters. And then that looks a little bit better. So that's it. That's like the body of the mug. That's the concept of the mug. It's really only three distinct parts. It's the main shell cylinder of the actual vessel that holds the fluid or the liquid, whatever you're putting in there. It's these trapezoidal arms that support the handle, and then it's a handle which is just a rod. And when I was in high school, I made this out of ceramic, and I really liked it, but I don't have it anymore, unfortunately, which is one of the reasons I wanted to remake it. So now we have to make this parametrically in Babylon. We could totally do this parametrically in Fusion, but Fusion is like $600 a year. That's a complete ripoff to just do this. We can implement that. We can implement all of that functionality from scratch in code pretty straightforwardly, I think. But I might be jinxing myself, but let's just jump into it. So let's go into VS Code. I kind of have some boilerplates set up here, just copied over from the other steel building project. So I think I have to just come in here and delete a lot of like the boilerplate that we don't need. The routes, structure view, profile maker view. We don't really need the profile maker view. We'll just do like the mug view. And then we'll have to create a component called mug view. We also need to import everything. Or sorry, install everything because it's a blank project. We're 8 minutes in. We're about 1 mile in. Nice. I think we're really doing well right now in terms of pace. And then the views, we don't really need the profile maker view. The structure view, we'll rename that mug view. And then let me just clear a lot of these errors by running pnpm install. And then let's build, or sorry, we don't actually want to build. We want to just dev. We're going to go to localhost 5173 to see what we're working with here. I think the router, we never saved that router file. Okay. Are you guys able to see? Yeah, you can see it. It's just saying failed to load profiles. So it's just a blank background because of that. Let's go back into VS Code and just clear out all of those errors by deleting a lot of the boilerplate that we had. Not the boilerplate, but a lot of the old code. So we're gonna want this. We're gonna want the engine, the scene, the camera, the shared materials. That's all fine. The parent container. Yeah, that's good. We're gonna want a parent container too, as like our main relative origin where we'll position all the elements. Engine, shared materials, shared steel material. Yeah, we'll just leave that for now, and the mug will be made out of steel, and then we'll change. We'll do like a ceramic material. Maybe we'll even have a material option drop down. We want the camera, the controls, the lights. That's all good. The ground size in meters, that's way too big. I think the mug, I mean, it's not gonna be more than like 200 millimeters tall, as a reasonable size. So we probably want maybe like 300 millimeters, or we'll just do half a meter. We'll just run a half a meter. That the grid, we might have to change that, but let's leave those for now. And then the profile options, we don't need any of those. Don't need the random section colors. These are all the This is all the code that actually draws. I'm gonna comment this out because I'd rather just look at this code than like go back into the Babylon documentation. And then let's just do a really simple. Actually, no, this should be fine. Where are we getting errors at? Oh, load profiles. Oh, right. So this is where when the component is mounted, that's when it actually draws the structure. So the draw complete structure, we just got rid of that. The load profiles, we don't need profiles anymore. But basically we'll do like draw complete mug or something like that, and then we'll probably rerun that every time one of the parameters changes. We're gonna also have to create like a little input overlay for the parameter. Let me go into the dual view so you guys can see both. I think that'll let you see both the yeah. I don't know why it's still saying profile not found. Did we not save our work? No, we totally did. I think it might be loading the profiles somewhere else. Not in the index, maybe in the main app. No. There's no utils, right? American flange. Oh yeah, well this. We can also just look for this profile. We can just look for not found. We can just search the project for not found. And that should, oops. I'm not used to this particular editor configuration, so I can't even find the search option here. And that's one of like my most, oh yeah. Oh yeah, okay, so we're importing this. Okay. Is this getting better? No, it's not. Maybe we'll restart the dev server. Maybe that will help. No, it didn't. Okay, that's okay. Router, the app. So it looks like everything is boilerplate except for these views. Inches to meters, feet to meters, those are fine. We can keep those utils. Okay, yeah, everything is boilerplate, I think, except for the mug view. Everything is happening in this component. Let's just search. Or it's probably going to be a string literal. Yeah, so this profile not found error is in this commented out string literal right here on line 121. So there's really no good reason that should be showing up in our code. right now. Let's try and think through what's happening here. When we mount it, we're setting up the scene. This is all just like standard Babylon boilerplate setup. We're setting up the scene, we're creating the ground. We commented this out, so this shouldn't, well, this function doesn't even exist anymore, so we'll just delete it. We're creating the ground, we're running the engine, and then we're setting up the scene. So is there anything happening in the scene setup? No, this is all Babylon boilerplate. Is there anything happening in the ground creation that could be invoking something to do with the profiles? No, it's not. Also, this is like not fully reloading actually. So sometimes it does. Sometimes you do fully need to reload the window. Okay, there we go. Yeah, it was just one of those annoying situations. Okay, cool. So that's our little half-meter ground. And then you guys can't see that properly, so that should be better. Let me move this even further up until, yeah, there we go. Now you should be able to see that pretty clearly. So this is this little patch of ground is our little half-meter ground. It looks like we do need to fix this the reference axes are massive. We need to fix that for sure. Let's go in and do that. Where are we drawing those? The helper, the axis viewer. So this is, I think 2 is like the size in meters. So we probably want it to be like, I mean, our mug was like around 100 millimeters tall. So we probably want it to be maybe, it might be helpful if it was like 120 millimeters. So 0.12 meters. Let's reload that. Yeah, there we go. That's a lot better. And then it looks like if the camera gets too close to the ground, it starts culling it or cutting it. I also really don't like how the camera keeps going through the ground like that and then popping up on the other side. We might do something about that later if we have time at the end. And then our grid isn't right too. I think the 1 unit per major square, the units that we're working with is 1 meter. So we want the major squares to be maybe 10 centimeters. I think that's okay. So we'll just do we'll change that to 0.1. And then let's see what happens when we do that. No, we're still not. We're still not actually seeing the ground or the grid on the ground. Grid ratio. We could look at the documentation and actually figure out what this is, but these comments are kind of helpful. 1 unit per major square. And this used to be 1. The units that we're working with is meters. So 1 meter per major square, that would be way too big because our ground size is only half a meter. 0.1 meters or 10 centimeters per major square. That should make sense and that should be drawing. Maybe the major unit frequency isn't right. Maybe we have to change this to 10 since we're working with a tenth of a meter. No. Oh, are we not even drawing the grid? Yeah, we weren't even drawing the grid. Okay, that's working because it's it's 1/2. Well, it's 1, 2, 3, 4, and then half grids on the other side. So that's 5 total grids. which is 50 total centimeters. So that's what we're expecting. So it looks like we're set up in terms of boilerplate, or just in terms of like the scene. We've got lights, we've got a ground, we've got a grid, we've got this axis helper. We should try and reestablish what the axis helper actually is. Let's comment this down too so we don't forget. Oh yeah, this is a no AI challenge, but I have Copilot just like auto enabled. But I'll try my best to just ignore it and just press escape as soon as it tries to just suggest something. But we won't be using OpenAI to search. We'll just be going right into the documentation. We won't be using any AI search tools. We won't be using Claude Code, and we'll be avoiding Copilot as much as possible. I could probably disable it if I wanted to as well, but I don't really want to go into the weeds. No. Yeah, I don't want to go into the weeds of VS Code right now and try and disable it just for this project. So we'll leave it enabled and just shoo it away anytime it tries to suggest something. Okay. I think red is X. Yeah, so Copilot is so fucking annoying in this case because it's kind of doing a good job of anticipating what I was gonna say anyways. But yeah, red is X, green is Y, blue is Z. I kind of feel like I need to disable Copilot because if I don't, okay, configure inline suggestions. Disable inline suggestions. Okay, cool, cool. So now Copilot is gone and it won't be suggesting those things, and we can be purists and truly avoid using AI on this project because I thought it'd just be really boring. This is something that I think Claude Code could do pretty easily, honestly, but it's just so much more interesting and fun if you do it yourself and actually think through the problem. Okay, so we've got the ground set up, we've got the scene set up. We can start drawing things. So I think we need to go into the Babylon documentation. Let me go over to Safari, and then hopefully you guys can see that. Let me double check for you. Yeah, you guys can see that. And then we'll just go to babylonjs. Actually, we don't really need to go into the documentation, to be honest, because is it learn or specifications? Like what? Why? Yeah, okay, there we go. Because we have so much example code that we just commented out, and I'd kind of rather just look at that and try and figure out how it works through that. So it looks like draw row. No, we probably want the draw profile situation because that will be drawing the mesh. Let's just search this for like create mesh or just mesh mesh builder. Yeah, mesh builder dot extrude shape. That might be the move. I think the trickier thing is going to be building the shell. We might have to use a like a Boolean operator on that by building the cylinder for the whole, like the outer cylinder for the mug, and then another inner cylinder, and then subtracting that inner cylinder from the outer cylinder. I think that's probably just going to be like the most straightforward way to create the shell of the mug itself. So I think I'm going to do that. Um, in which case, we probably do need to look at the documentation because I don't think any of that kind of Boolean mesh building was being done in the previous code marathon. So let me go back and pull up the documentation. Okay. Features, introduction, deep dive. Let's just go into the API maybe. And let's look up Boolean or intersect, Boolean geometry operations. That looks promising. Boolean geometry block, flow graph Boolean to flow graph Boolean to int. No, that's probably not what we're looking for. Switch Boolean action, rich type Boolean. I don't think this Boolean, yeah. Oh yeah, intersect, subtract. Yeah, this is actually probably what we want. Boolean geometry operations by the Boolean block. So let's go to the Boolean block. Boolean geometry block. Oh, this is a node. This is one of the node builder things. This is probably not what we want. We're gonna have to just go, we're gonna have to DuckDuckGo this. Babylon mesh intersection subtraction. Mesh intersections, nice, nice. In dynamic scenes, no, this is not what we want. This is looking at collisions. Oh, interactions. No, yeah, that's confusing. Moving mesh subtraction mesh. Okay. Babylon mesh. There's a word for this, and I think I forgot it. Like when you combine two meshes, like there's like a three-letter, yes, CSG, constructive solid geometry. That's it. That's it. Wait, was this an AI suggestion? Oh my God. No, it wasn't. It wasn't an AI suggestion. We're good. We're good. Um, let's configure this too, so that we don't taint this project with any AI. Okay, constructive solid geometry. Babylon. Let's just write CSG. Yes, this is what we want. Whoa, is this deprecated? Okay, CSG2. Let's go, CSG2. Let's go back to the documentation. CSG2. Is CSG2 ready? What? There we go, CSG2 class. This is what we want. This looks like a good example as well. Oh, this is a playground. Perfect. Perfect. Yes, that's exactly what we want. So I think we'll just be able to build the two meshes and then use this CSG2 class to add them or to intersect them or subtract them actually, and then run two mesh to get the final mesh for the shell that we want. Nice. Let's go back to VS Code and start scaffolding that out. So we kind of have like those three or those two or three main parts, three parts really, of the mug. So we'll do a function called create shell, I guess. I don't know what to call that part of the mug. It's kind of maybe it's the cup. Yeah, it's the cup. I kind of like using draw as well as like my verb for functions that draw things. So draw cup. And then I don't know if we should pass it the arguments for like this is a function that's just gonna take the scene because the scene is a global variable and just put the mesh in the scene. Or we could write it as a function and architect it as something that has no side effects and just returns a mesh and says, give me the parameters that you want for this mesh and I'll just give you the mesh. I think for like a draw function, I'm kind of preferring something that has no side effects and just gives you a mesh based on the parameters that you give it. So let's do it like that because if we have two meshes, we could do if we really have a lot of time at the end and we want to do a victory lap, we could do morph targets and um, morph between the different sizes as the parameters change. So draw cup. Let's go back to our fusion model. And Look at the cup. It has a height. It has an outer diameter, or has yeah, it has an outer diameter, an inner diameter, but I think I would prefer to just say wall thickness. And then it has a bottom, so we could just say bottom thickness. And I think those three numbers will define the cup. We can define a cup in just three numbers. So let's go back to VS Code and draw this cup. So we have height, that's a number. We have the diameter. We can be a little ambiguous with it because I think once we say wall thickness, it'll become clear that the diameter, actually no, that's not clear enough. We should definitely say outer diameter. The OD, and then again, wall thickness isn't really that clear either because that could also be the bottom thickness. So we'll do sidewall thickness. And then we'll do bottom thickness. And I think that's it. And this should return a babylon.mesh. Cool. And then we also have the trapezoidal brackets that hold the trapezoidal arms or brackets that hold the handle to the cup. So we'll do a function for that. Draw brackets, I guess. I don't know what to call those. I think bracket is probably the best word. And then let's go back into Fusion because we have to think about what parameters define those. And it would probably be best to look at the sketch that we did and look at the dimensions of that. So we have, I guess we have this is the base. So we have like the base size, the base length. And then we have the end length, I guess. No, that's not a good word for it. This is for sure the base though, right? The base length. Yeah, we can just call this end length. I don't want to waste time like picking the perfect variable names. Um, and then the question is, should we define them as half lengths or define them as full lengths? Because it is a symmetrical. We used a mirror, and this trapezoid is always going to be symmetrical along the axis that's perpendicular to the tangent of the cup. So we should probably use a half length, honestly, just because I think that insinuates that symmetry a little bit better in the parameter itself. So we'll do like the base half length, the end half length, and then we'll do the protrusion length, which is from the tangent to the end. And then we also have the handle diameter, and then we have the tangent to handle extension distance. So again, we decided to define this handle offset. So I think we'll call this the handle offset length, and that will be from the tangent, or yeah, from the tangent to the cup to the center of the handle. So I think that's it. So we have 1 base length, base half length, 2 end half length, 3 extension length or extension distance or length, same, I guess, same word in this case. And then we have the handle diameter, and we have the handle offset length. I kind of like throwing length in the names because it helps differentiate between diameters and lengths. And then that's good. And then also I can already see that there's a couple like design rules that we'll have to enforce. And we'll probably create a function called like design rule checker. For example, the base half length can't be more than the radius of the outer diameter, or half the outer diameter. I mean, I guess it could, but then there would be like an extra an extra portion of the base protruding out the side. So we'll probably enforce that as a rule. But let's go back to VS Code and then scaffold out that function. So draw bracket, we had 5 things. We had the base, half length. We had the end, half length. These are all numbers. We had the protrusion. We call it the height. No, that. Oh, and we have the thickness too because it's 3D. So there's actually gonna be 6 things. We have the. I guess we should call it extension. Yeah, extension length. I don't know. We can't get too caught up into naming these things perfectly. Spell check is not AI, by the way. Extension length. Um, the handle offset length. I feel like this is more of a distance because it's not like a dimension really that defines the shape of the mug or of that particular component or piece. So again, this is just completely unnecessary semantic nitpicking. Handle offset distance, and then we'll do the handle diameter. And then we'll do the thickness. That should be 6 things then. 1, 2, 3, 4, 5, 6. Yes. I think those parameters will define the bracket. Babylon.mesh. Also, auto suggest is not AI. These are all pre. Any tool that existed before LLMs came out is free to use. Okay. Um, we've got the cup, the bracket, and then just the handle, which is really easy. So function draw handle that just has a diameter and a length. I guess we could call it a height. We might call it a height just to keep it consistent with the cup function. And then we'll also just swap the order of those to keep it consistent with the height, to consist with the draw cup function. Again, totally unnecessary, but I don't know. I like to keep my code a little bit clean and logical in every way possible. Okay, cool. And then we have to actually like assemble all of these into the mug itself. So we'll do a function called assemble mug. And then I feel like this should almost accept all of these parameters. So if we're gonna have to redefine those, we should probably turn them into separate types. Type, we'll do this like cup parameters. Um, I guess we'll just copy these in. I haven't copy and pasted like this in so long since Copilot came out, but here we are. Good practice. And then why? Oh yeah, this wants an equals sign here. It's so important to, I think, code without AI, because otherwise you'll just forget how to like copy and paste things and do like basic syntax type work. And then we'll call this params cup parameters. Okay, cool. Yeah, we'll do cup parameter type bracket parameter. Yeah, I prefer to do semicolons when I'm doing my types. It just feels like if I'm not doing a semicolon, it's like it feels more like an array or something like that, you know? But with a semicolon, it's like this is like a different thing, like an object. And then we'll do a type handle parameters, I think. This should be plural. Handle parameters. Um we won't even copy and paste this, it's not worth it. Height, diameter. Am I spelling that right? Yeah. Number. There we go. Cup parameters. Params. I don't like using word like params. It's such a like, especially when I'm writing code. Like it's such a generic word in any code base. But it's okay. I'll let it slide for this marathon. And then we'll do a we'll do params bracket or no, handle parameters. Okay, cool. And then I guess this mug, it doesn't just assemble it because it's like drawing. So we'll just do create mug. And then we'll do um cup params. We'll do bracket params. And then this doesn't just return one mesh, right? It should return, I guess, a container that has the mesh, but that's yeah, now we have to kind of think about how we want to like model this out because I mean meshes can contain submeshes. Meshes are really just fairly generic containers in Babylon. Meshes can contain children. So I guess we'll just make it a mesh. Or no, we'll make it a container. Is there like a mesh container object or no? Just what are we doing? What was the parent container? Transform node, that's what it is. Okay, so we'll just yeah, we'll define that as a transform node. And then we need more parameters because in addition to these components that comprise the mug, we need to define the relationship between them. So let's go back to Fusion and look at that and start thinking about the relationship between the different components. So the mug is kind of like our central, or the cup is kind of our central reference element. So we'll leave that. It doesn't really need like this should be the origin, I think, of the transform node. And then we have for the handles we have two parameters. We have the the bottom bracket offset and the top bracket offset. And I suppose we could always model that as like bottom bracket offset and then this distance between these and then have a design rule that says like this distance has to be less than the bottom bracket offset plus the bracket thickness plus the bottom bracket, yeah, that has to be less than the bottom bracket, has to be less than the mug height minus the bottom bracket offset minus the bottom bracket thickness minus the top bracket thickness. Or we could just say bottom bracket offset, top bracket offset are two positive numbers, and they have to be greater than 0. Um, from a design standpoint, it almost feels like as a designer you would care more about that distance between the two brackets because that is the important parameter for the usability of the mug. And so if you were designing the mug and you were trying to make sure that that distance was enough for someone to put all 4 of their fingers minus thumb. I don't know if there's a word for those 4 fingers, but all 4 of like their main fingers um, inside that, within that distance, then you'd have to be doing the mental math internally to like subtract the bracket offsets from the height of the cup and the bracket thicknesses and stuff to figure out what that distance was. So I almost feel like it would be better as a parameter to say choose the bottom offset and then choose a height between the brackets, and then we'll have a design rule that restricts that height to make sure that the top bracket, isn't going over the height of the mug itself, over the top of the mug. So I think I'm gonna go with that route. We'll do like a bottom bracket thickness. I actually don't really need to write this down. We'll do a bottom bracket offset and then a bracket distance. So let's go back to VS Code. Actually, no, let's stay here and figure out all the parameters, and then we'll do them all in VS Code at once. So we've already defined this distance actually, right? Within the design, or within this 25 millimeter distance is already part of the bracket, is already defined by the bracket. So I guess we don't need to redefine that. We probably shouldn't. The only other thing left is the the distance between the bottom bracket and um, distance between the bottom bracket and like this protrusion length of the handle coming off the bracket. And I guess that's just one distance because the height is fixed. These these distances are going to be fixed by the bottom bracket offset and the bracket gap. I think we'll call it, yeah, I think we'll call it bracket gap. I like that. So really we only need one number to say how far do you want the bottom of this piece of the handle to be from the bottom of the bracket, and then that's whatever the bottom bracket gap is and whatever the handle height is just gonna determine what this distance is at the top, or what the top protrusion is. So wow, there's really not much to it when you think of it that way. Um, let's go back to VS Code and put that all on paper. So we'll create another type and we'll call it type mug assembly parameters. And I think we had 3 things at the end there. We had the bottom bracket offset, and that was the distance from the bottom of the mug to the bottom of the bottom bracket. And then we had the bracket gap, which is the clear distance between the top of the bottom bracket and the bottom of the top bracket. And then we had the handle bottom bracket protrusion. I mean, I think offset is probably just better to keep it consistent with what we've been using. And that's it. Is that really it? Wow. Let's just play with the fusion. I mean, we like we'll run into any omissions as we design the as we continue to write the code, but let's just think about this a little bit longer. This flat section here, this flat section here is throwing me off because it doesn't have to be flat. This could continue on. And I don't know why. Well, I guess it's flat because we define the tangent off of the outer diameter. But if we define the tangent, like if we didn't have this tangent and we only had, I guess we could just define this distance up here, this end, the end distance, and then define like an angle between here. And then that would have to be, dang, I'm kind of preferring that because this whole flat section is always going to be there if we define it this way off of the tangent. And I don't know how I feel about that. I don't know if, I mean, let's just look at the design. Like, I don't hate I don't hate that. I kind of like the way that looks from the top. Um, it looks like a little bit more than just a triangle going into a circle, which I kind of like. And then I kind of like how this distance complements like the size of the handle. And it just adds like a facet to the design, which I don't dislike. I kind of like actually. But we should probably try and model it the other way just to see what that looks like. What would happen if we just deleted this face? Oh, okay. Um, Let me copy this whole thing. Move it over like 200 millimeters, and then let's delete these faces. We can kind of see like which way we like it better, and then we'll also think about whether or not it's possible to do it parametrically such that you can actually configure whether or not that face will exist. Hmm. I might have to consult a friend on this. What's our timing right now on the marathon? Let's go. Our timing right now is 7 miles in. We're an hour into our 3 hour marathon. We're like a third of a way into this. Yeah, I'm gonna quickly consult someone to see what they think. And if they get back to me soon enough, then we'll roll with their opinion. Why are these so far apart too? Like it's making it hard for me to get like a good picture of having these side by side. Let's move this back. I think it was 200 millimeters apart. So let's move it back 100 mils. They're only 100 millimeters apart. Yes. Okay. I think this one view actually captures the differences enough, but I'll give them give them a little bit more. Okay, cool. Which design do you think is better? One of them has a bracket with a flat facet that joins to the cup portion of the mug, while the other just has a straight angle, just has one angled face that joins the cup. All right, we can keep going. Well, while we're waiting, let's think about whether or not it's possible to actually um, parametrically design this as an option. Like, could we? I mean, right off the bat, we could define like a cutoff distance, right? Like a distance from this tangent, a cutoff distance of 0 would result in this kind of a situation where there's like a tangent where this line is right on the tangent, and then you get this flat section, you get this flat face here. But then if we brought the cutoff distance up, just to show you by way of example, um, well, okay, that's not going to work. Maybe if I copied these and then moved them, yeah, you could see like if we brought the cutoff distance up, then this would become like it would become flat here, and then it would become flat from where this cutoff line intersects with the angled line of the bracket back towards where it intersects with the cup. And then if the cutoff distance is far enough back where it's further away from the point where this angle, if it continued, would intersect with the cup, then it'll just simply intersect. But then we start getting into like a little bit more complicated set of design rules, because we have to look at, well, first of all, we'd have to figure out how to actually define the trapezoid again, because right now it's defined with a cutoff distance of 0, and the cutoff line is the base of the trapezoid, and we're defining that length. And then so we'd have to probably pivot to a end angle, or an end length and angle, like obtuse angle type of definition for the trapezoid, which is fine. I think that's a perfectly okay way to define the trapezoid. Um, and then we would have to run a little bit of trigonometry to make sure that the resulting triangle isn't greater than what isn't great doesn't end up becoming greater, or the base of the trapezoid doesn't end up becoming greater than the diameter of the cup. Similar to how we have a design rule where the base can't be larger than the diameter. Hmm. We're an hour in. Honestly, I think we should just go with the more complicated option, because That sounds more fun. Let's do that. I'm definitely curious to see what to get the other person's opinion on the design, but let's go ahead and make this more complicated. All right, back to VS Code. I was wondering if you guys, yeah, you guys can see me when we're in the VS Code view. Oh, we're exactly an hour in now too. Perfect. All right, we're doing this. We're doing this. So that completely changes the bracket parameters. The base half length is no longer in play. We have the end half length. We do still have the extension length, the offset distance, but now we're working with, I don't like this. Why isn't this auto formatting? Oh, it is. Okay. We no longer have the base half length. We have the, I guess we could call it a draft angle. And this is a number, and we should say that this is going to be in radians. Just I like using radians just to be obnoxious, but the actual inputs on the slider will for sure be degrees, and that's maybe we should start commenting these parameters with like the general design rules and constraints that they have too. So this is going to be radians, and going back to Fusion, it has to be, it's going to be this angle right here. I'll turn on the inspect tool so you could see it. It's going to be this angle, and it's going to be obtuse. It has to be greater than, does it have to be greater than 90? It technically doesn't. It just has to be large enough that the lines don't intersect when they meet back at the middle. But then you start getting into some really weird stuff where like they could intersect before the handle has enough room. So we'll definitely just make it that they have to be at least 90. So it has to be greater than 90, and it has to be smaller than whatever is going to end up wherever it's going to end up intersecting with the cup. It has to actually intersect that circle. So we could think about that design rule check as two ways, like either making sure that this, running like a simple intersection type formula, or doing like intersection math, making sure that this ray will actually intersect the circle, or we could just do simple trigonometry, making sure that the base of the trapezoid, the resultant trapezoid, is going to be less than the diameter. I think we'll probably just do that, like the trigonometry approach. But again, it always like there's always so many different ways to do things, and I think that's interesting. But okay, so that angle, we're going to call that the draft angle. Maybe we'll call it the trapezoid draft angle, but again, no need to waste time on the naming semantics here. I think you guys get what I'm saying. So let's go back to Fusion, or sorry, let's go back to VS Code. Radians must be greater than 90, so that's what, pi over 2? Must be greater than pi over 2, and must result in a trapezoid, must result in a trapezoid base less than, I'm going to use the symbol here just for consistency, less than cup parameters dot outer diameter. Okay, cool. And let's look at this. Let's look at height. This is unrestricted. So I guess we shouldn't even say that. We should just leave it as is. Outer diameter, that's unrestricted. The sidewall thickness must be greater than 0, and it has to be less. I think it has to be less than half the outer diameter, because then if it was exactly half of the outer diameter, then the cup would be solid. And if it was anything greater than that, it would just, I guess, be like, um, yeah, it would go past the the inside of the cup, which wouldn't make any sense. So must be less than cup parameters. Do you guys think that we should reference cup parameters dot height, or we should just say height divided by 2 because we're already within the cup parameters type? That's a little question. That's a little question to ponder on for designing a code base. Must be greater than 0, must be less than cup parameters dot height divided by 2. Or you could say this dot height divided by 2, but that'd be kind of dumb. And then bottom thickness, this just has to be less than the height. Must be less than this dot height. No, I'm kidding. Cup parameters dot height. I think that's it for the constraints, for like the local constraints of these values. Bracket parameters, the end half length must be greater than 0. And I suppose it has to be less than half of the cup parameter diameter, because yeah, it has to be less than that, because if it has to be at least 90 degrees or pi over 2 radians, then at if it were 90 degrees and it was exactly the end half length, or if the end half length was exactly half of the cup diameter, then you would just basically get like a rectangle coming off, meeting the two and being tangent to the two parallel ends of the cup. So must be greater than 0, must be less than cup parameters over 2. And then the extension length, that is unbounded, I believe. I mean, yeah, it's unbounded, but if the draft angle, is anything over 90, then you'll get some pretty, the base of the trapezoid will blow up as the extension length goes up. That's a linear relationship. So it's bounded in that sense, but it's not actually, it, this value itself is not bounded, it bounds the draft angle. So this is unbounded, we'll leave that empty actually. And then the handle offset distance, this has to be less than the extension length. This has to be less than the extension length minus, because this offset distance is from the tangent of the cup to the center. Yeah, we should run it to the center of the handle. So it can't go past, like, I mean, realistically, the handle can't be right. Actually, it could be. It could be right at the edge, tangent to we can go back to Fusion to visualize this. But like this, we'll use this one because we don't really care about it. But this can't be, what's going on? What's that, body 6? Yeah, so the handle can't be like anywhere past this point. Oops. Okay, so now we're in Fusion. The handle can't be anywhere past here, right? Because if it goes past, I mean, again, I guess technically this is fine. This is like theoretically constructible, right? As long as there's some attachment, as long as there's some contact. Whoa, whoa. I don't know what just happened there. As long as there's some contact between the handle and the bracket, it should technically work. Like this could be a viable design. And it does kind of look cool, actually, so I want that to be a viable design. So I guess the bracket, the handle offset distance just has to be less than the extension. Actually, no, it could be more than the extension. It has to be less than the extension plus the handle radius. So that's kind of cool, actually. Okay, so let's go back to VS Code. So this has to be, must be, I don't know why I formatted it this way. Sorry, I'm going back to this. Must be less than 2 pi rad. That makes a lot more sense. Um, actually, no, it does. Well, it makes sense to kind of say this is going to be in radians. So the way I had it did actually make sense. We'll do something up here that says all angles in radians, all distances. Well, distance is technically like the right word, but I guess length for like a unit. Like a length is a distance, an offset is a distance, and a distance is a distance. So we'll just do, yeah, all distances in meters, which is the base units. So, okay. So the handle offset distance, it must be less than the extension length plus the extension length plus the handle diameter over 2. We're doing a lot of like over 2s, which is kind of making me wish that we did radiuses or radii for all of like the circular, the diameter parameters, but it's okay. I like diameters as well. And then I guess we'll just be consistent and make sure that these are like defined relative to the parent object or the parent type. And then the handle diameter. This is interesting. This handle diameter is really interesting because again, technically it could be like unbounded. I think we can use the yeah, we can use the offset face tool, I think, to just like expand this. Yeah, like technically this is fine, right? Like this is totally constructible. Um, we could keep more simple design rules and say it has to be less than, it can't go past like the edges of the, we could say this is fine, but then once this starts to happen where it goes past the edges of the bracket, we could say that's not okay. But again, that's also pretty difficult to define, right? Because that's dependent on the draft angle, the draft angle of the bracket, and the extension distance of the bracket, and the offset of the offset of the trapezoid, or sorry, the offset of the handle. But I think it makes the most sense just to say that it has to be like the radius has to be less than the offset distance because this is fine. This is like I guess technically fine, but once from like a constructability standpoint, but once the handle starts coming into the cup, that's when it's like, yeah, maybe technically constructible, but like it just starts messing with the cup, and that's it messes with the integrity of the cup as like a simple shell cup. So I don't think that we should allow that. Although, yeah, that could be kind of cool if it continued into the cup. Um, but probably really impractical as a handle. So we'll set that one rule for it and then see what happens when we actually implement the parameters and start sliding things around. And one thing we'll also do is create like a random button. I think that could be really fun. Okay, so we'll just say that this has to be, this is the handle diameter, right? So we'll just say that let's go back to VS Code. We'll say that the handle diameter has to be less than the handle offset distance. Must be less than cup parameters dot handle offset distance. Easy. And then the thickness, this just has to be less. Well, this is going to be influenced by the mug assembly parameters. Or rather, I think the mug assembly parameters might be influenced by the thickness. Because if these are two, let's go back to Fusion, I'll show you. if these are too thick, like if these are way too thick and then this offset between the handles isn't enough, the handles will like intersect, right? So like, I guess we should allow them to be, well, there's two of them, so they can't be more than, there are two of them and then they're same thickness. That's another thing about these parameters that like we're kind of locking in that we don't necessarily have to lock in. We're saying that the brackets have to be uniform thickness. Both of them have to be the same thickness or identical thickness rather than uniform. So I think it's okay if we set that constraint. Like this is already getting pretty complicated with the whole draft angle thing. So we'll just say that the brackets have to be the same thickness, in which case they can't be more than half of the height of the cup because then they'll be forced to intersect and we don't want that. So we'll go back to Fusion and we'll just say that must be less than, wait, this isn't cup parameters. This is bracket parameters. Also same with this. I'm using the cup parameters. Okay. Okay, sorry. I just noticed that because this is actually a cup parameter. It must be less than the cup parameters dot height divided by 2. Um, yeah, the brackets are identical because that's okay. Um, because we're only passing one bracket parameter value to the create mug. If we had two brackets, we'd have to do top bracket and bottom bracket, and then we would have more design rule checks, and that would blow up the complexity, I think, beyond what we can complete in this marathon. Where are we on time, by the way? Are we already at? Oh, okay. We're 17 minutes past the hour. We're good. We haven't really accomplished much though. We've just sort of, well, we have. I guess we're just defining these design rules, which is going to be pretty important for implementing the create mug function. Okay. Um, and then the handle parameters, the height. Okay, this is interesting because the height technically doesn't have to be less than the height of the mug because it can come up. Like if we extrude this up, we can go up as much as we want. Um, and that could be kind of funny too. I think yeah. Like there's no reason that we couldn't go up like this. We just can't go, well, we technically could, again, from a constructability standpoint, but from like a usability standpoint, we just don't want to go, we don't want this. I guess we have to think about two things when we define these parameters. Like, do we want to create a constructible mug or a usable mug? Because those are two very different things. I'm noticing. Like, this is a constructible mug. I guess it's technically a usable mug too, but like, not really, because how would you put this down? You'd have to put it down at the edge of a table so that so that the base of the cup could lay flat. So I don't, I kind of want to allow that. I think it could be funny, but also I kind of don't because, well, it actually wouldn't blow up the complexity. It would, I think we need two functions. We need one called create mug, and then we need one called create usable mug. Create mug will always be guaranteed to create a constructible mug, whereas create usable mug will always be guaranteed to create a usable mug. And those will be two different sets of design constraints, which kind of throws off all the comments that we just put in, because we've been assuming that we just want to create a usable mug, or sorry, a constructible mug. And hmm, we'll have to create two separate sets of design constraints. I was also just thinking about like the random cup generator function. Oh wait, we got our I think I prefer the one with the single facet. Okay. That's good because that's the direction that we're going in to enable that. Okay. I'll send you the results in 2 hours. Cool. Um, okay, so they like this one better. The 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 one with the simple triangle here. Which is, yeah, that's good because that's what we're doing. So we got to go back to the usability versus constructability conversation. Those are two completely different sets of constraints. Um, I guess the usability constraints are a subset of the constructability constraints. If it's not constructible, it's not usable, I guess, or if it's not constructible, then yeah, it's not usable because it can't be made, so it can't exist. So let's first do a constructible cup, and then we'll come back and we'll make a more constrained set that is usable, guaranteed to be usable. So if that's the case, then these these handles have no limit on their length from a constructability standpoint. So let's just go to VS Code and say these are unbounded. And then again, the handle parameter, the handle diameter, C, we'll just say C bracket parameters dot diameter. C bracket parameters dot handle diameter, because that's just going to be like, we probably shouldn't even have this because we're passing the same value. We're passing the same value in two different places to create mug. And I guess we could just have a simple thing in create mug that's like, are these values the same? And if they're not, then it's a bad set of arguments. But and then I'm also wondering, like, should this be part of the bracket? Not really, right? Like, I mean, the bracket does need a hole in it, I guess, from a construction standpoint, but even then, not really, because we don't know how it's going to be constructed. It might be constructed in a manner, like if it's 3D printed, that hole isn't going to be part of the bracket per se, so it's just going to be one monolithic body. So I think I'm going to I think I'm going to move handle diameter from the bracket to the actual handle itself. I think that makes more sense from like a code, from just like a logical architecture standpoint. And then the height is unbounded. Okay, and now let's go through these and do separate, like, and define like the constructability and the usability constraints as well. So the height is unbounded in both terms of constructability and usability, technically speaking. Like, if we, if there were people that were 10 times larger than us, they would be able to use it. So the height doesn't actually affect the usability, and I don't think we should put like specific numbers on things. We should think of usability in terms of like, can you put the cup down? Is there anywhere where you can actually grab the cup? Those kinds of constraints, but not necessarily like, is the cup too big? I don't think that should be part of the usability question. I think usability is defined by, can you put the cup down on a flat surface? And can you hold the cup by the handle? Those are kind of like the only two usability constraints I can think of. So let's look at the outer diameter. Oh, well, I guess, yeah, from a usability standpoint, we should also say that, like, well, it could be less than or equal. Must be greater than 0, must be less than or equal to 0. And then let's just say usability must be less than the cup parameters. Wait, why is this cup parameters dot height? This should be cup parameters dot outer diameter. And then the bottom thickness must be less than cup parameters dot height. And then usability. Again, this could actually be equal because then it would just be solid. If the bottom thickness was equal to the height, it would be solid, and that's constructible. But from a usability standpoint, there wouldn't be any empty volume in the cup to fill, so it must be less than. Must be less than that. And then maybe we could set like ideally it should just be equal to the sidewall thickness. But no, we won't do that. Maybe we'll hard code those kinds of constraints in like our random generator, and we'll have different random generators, like a completely random generator. We'll have like a generally usable random generator, and then we'll have like this will randomly generate like nice, reasonable cups that are like comfortable and like very usable and very practical and something that people might actually want. Okay. And then the end half length. It must be greater than 0. It must be less than the cup parameters dot outer diameter divided by 2. I mean, I guess from like a usability standpoint, we should like you can always grab the cup, I guess. Um, or sorry, yeah, from a usability standpoint, that's always going to be usable, I think. The draft angle, yep, that doesn't affect usability. The extension length doesn't technically like affect usability if it's not like, you know, well, I guess you could calculate like the torque that is put on your wrist by the weight of the cup if it's like an extremely large extension, but if it's an extremely large lever arm created by the extension, but we won't get into that now. Handle offset distance. That doesn't really affect usability as long as it's greater than 0. Well, yeah, that's actually another constructability constraint. It does have to be greater than 0. Must be greater than 0. Well, I guess, yeah, most of these values cannot be negative, so might go without saying. Um, Actually, let's think about that. Yeah, none of these values can really be negative. And then from a usability standpoint, yeah, well, this could be greater than or equal. And then from a usability standpoint, if there's no gap there, there's no gap between the brackets, then there's nowhere to like for the handle to go. Well, I guess the handle could go up and you could grab it from you could grab it from the top. So I guess that doesn't affect usability either. Let's start thinking about positive. That has to be 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 positive. Um, that has to be positive. Yeah, that has to be positive. Either it'd be going in the wrong direction. The extension length does have to be positive. The handle offset distance does have to be positive. Otherwise, it'll start going into the cup. The thickness has to be positive as well. Um, okay. Yeah, all these values, bracket gap, yeah, all these values have to be positive. So all angles, all distance in meters, all values must be greater than 0. The handle height for usability must be less than, well, again, no, it doesn't have to be less than, just Yeah, no, for usability, it really doesn't have to be constrained. Um, that would be the handle bottom bracket offset for usability. Okay. Bottom bracket offset. Um, I might have to walk my dogs in a second and take like a 10-minute break. Bottom bracket offset just has to be greater than 0. Greater than or equal to 0. And less than the cup height minus the bracket thickness, because then the two brackets would just meet at the top. Has to be less than the bracket thickness, but then also the bracket gap comes into play here. I'd have to go back into Fusion to suss this out. So if this, the bottom, the bracket offset is this distance from there to there. It's that distance, and if that distance, I think we already talked about this, that distance plus the gap plus the two thicknesses has to be less than the height. So we'll go back into Fusion. Bottom bracket offset must be less than the cup parameters dot height minus, yeah, the bracket parameters dot thickness times 2 plus the mug assembly parameters dot bracket gap. And then the bracket gap, these are all kind of getting circular, which is weird because like the bracket gap is like going to constrain the bottom bracket offset. But then if the bottom bracket offset is set first, then it's going to constrain the bracket gap. So like depending on which one of these values is locked in first, it'll change the direction in which the constraint is applied. But that's interesting, and I think we should think about, I think that's a reason why we should think about the constraints relative to each value, because we don't know which one is actually going to get locked in first. So the bracket gap, must be less than the cup parameters dot height minus the bracket thickness times 2. Yeah, I guess this could also be changed to minus. There's no need for this to be in parentheses. There's no need for these parentheses at all, actually. Must be less than the bracket parameters times thickness times 2 minus the bracket offset minus the mug assembly parameters dot bracket bottom bracket offset. Okay. I need to go let my dogs outside. I'm gonna pause the marathon timer because we're already like halfway in and we're just kind of getting started on like the code. So I think it'd be kind of fair to like stop the timer, pause the timer, and then I'll be back. All right, I'm back. Unpausing the timer. Let's dive in. Let's dive back in. Okay. Um, we were defining the offsets, right? I feel like this is not, like, this commenting work is not going to be as useful as we think, like, I think it is, because I'm going to have to go back and kind of do all this partially again as I'm implementing the create mug function. But it's cool. It's kind of interesting to think about this ahead of time. Handle bottom bracket offset. This has to be less than the height of the cup. Definitely can't be greater than the height of the cup because then there'd be no room for the top bracket. Has to be less than the height of the cup minus um twice the bracket thickness so that there's room for both brackets along the length of the cup, and then it has to also leave space for the bracket gap. So that's it. It's interesting, like the relationship between these three parameters is really interesting. And then they all have this constraint must be greater than or equal to 0, but we can actually delete this because we already said that every value here has to be positive. Okay. We should get into putting things into our scene because I feel like we've just been like writing comments in the code basically for the past 45 minutes or more. So let's go back. Let's start drawing things really. Let's comment out these like empty functions for now. Let's comment out these empty functions and just tackle them one at a time. So draw cup. This is going to be the CSG, constructive solid geometry thing, where we have the outer. So const outer cup equals, I think this is just a Babylon dot mesh builder dot create cylinder. Yeah, create cylinder. And then we have the names. Let's call this cup outer. And then we'll say temp because it's just part of the CSG workflow. The height is going to be the params dot height. Is this diameter? Yeah, the diameter is going to be params dot outer diameter, and that's it. And then I think it will just take on like the default material, but let's see. Maybe we just add the material to the mesh that comes out of the CSG process. Const inner cup equals Babylon dot mesh builder dot create cylinder. Oops. Okay, and then this one's a little bit different. This we'll call it cup inner temp. And then this is going to be, the height is going to be the height minus the bottom thickness. And then I guess we could run like some of our design rule checks here too. Const is bottom thickness valid equals params dot bottom thickness. It has to be less than, we said that it must be less than or equal to the height. We'll just say I think an easier way of doing this is params dot height minus params dot bottom thickness is greater than or equal to 0. Yeah, I don't know. That's just a different way of saying the same thing and comparing them directly. Why did I do that? I don't know why I did that. I'm gonna change it back. It has to be less than or equal to the height. Don't know why I changed it to that other way of doing it based off of the 0. Okay, and then the height, right, we have that locked in, and then this is the height is already validated, and then the diameter. The diameter is going to be the outer diameter minus the wall thickness times 2. Minus params dot sidewall thickness times 2. And then we should validate that too. Const is wall thickness is sidewall thickness valid equals must be greater than 0. Right, we already we already said that all values must be greater than 0. And I guess in the assemble mug function, we'll do something that just checks that all values are greater than 0. Must be less than the cup parameters dot outer diameter divided by 2. Yeah, that makes sense. It can't be thicker than the radius of the whole cup itself. So params dot sidewall thickness is less than or equal to params dot outer diameter divided by 2. That's good. And then if I guess we'll throw errors. These functions will throw errors. Or we could use like a result type. But no, we'll throw errors just so we don't have to define a result type. If and again, like if one of these is bad, then there's no reason to check the other one, right? If bottom thickness is valid, the bottom thickness is not valid, throw new error, bottom thickness is not valid. Easy. Kind of want to just put these right next to each other because they're kind of like one block. If is sidewall, well, again, want to negate that. If is sidewall thickness valid, throw a new error. Sidewall thickness is not valid. These could be better. These could be better error messages. We're not going to worry about that. All right, so we've got the inner cup, we've got the outer cup. Now let's do the CSG thing. Let's just write it and then see if we get good like developer tips in the actual documentation in the code itself. Const CSG equals babylon.csg2 dot create a new constructive challenge from a mesh. I guess I don't know. Yeah, I think from mesh is the move. Let's go back to Safari and look at that playground. Our built-in sphere shape. Okay. Looks like they're putting materials on it. That's interesting. You could put materials on the mesh and it looks like it will apply those materials to the surfaces that are created in the CSG process. I wonder what will happen if we just don't give them any materials and we do it at the end though. Wait, so it looks like we need to run initialize CSG to async. Interesting. Interesting. I think we probably only have to run that once at the beginning. Maybe in our scene setup or something. Okay, I see. So we have to create a CSG object for each of the meshes involved in the construction, and then we can run the subtract method on the outer mesh, passing it the inner mesh. And then we'll run to mesh on the result. Okay. So I think up here in the scene setup, we were going to say um, set up the CSG manifold library. I don't know. I'm just copying what. I think this was an async function too. But yeah, we should probably make this async then, or we could just do it up here. But no, it's okay. We'll make this whole thing. Oops. We'll make this whole function async and then await it so that um, everything, the CSG thing is ready. And let me go back to Safari. What was it that they were running? Babylon.initialize CSG2 async. Babylon.initialize CSG2 async. There we go. Okay. So I think that should be good for setting that up. And then outer cup CSG equals from mesh outer cup const inner cup CSG equals babylon.csg2.from mesh inner cup. Nice. And then the actual construction process is going to be const cup mesh equals the outer cup CSG dot subtract the inner cup CSG dot to mesh. And we'll call this cup mesh. And then I think we only have one default scene, so we don't have to actually explicitly pass it the scene. And then I guess we can just return the cup mesh. We should probably give it a material. Is that, are we like defining global materials? Yeah, shared steel material. So I mean, we could define the material in the create mug function. Um, mug parent equals new babylon.transform node. Return mug parent. And then we need to add input sliders to this scene so that we can actually like input the values that we want. So let's go up to like our template. We have our canvas, and then I wonder, um, let's do a div. Do we have, I don't think we have Tailwind set up here. So we'll just give it an ID. ID equals inputs overlay. And then we'll do like some scoped styles on that. Let's just, yeah, we'll come down and do styles, scoped, and then by the ID, input overlay. That was the ID, right? No. Inputs overlay. I kind of prefer using underscores because that way you can just copy the whole thing, or using camel case, but using a dash for some reason is a lot more, is more common from what I've seen, but I don't like doing that, but I'll do it anyways, just to fit in, just to fit in with everyone else. We'll give it like an absolute position, and then we'll say I guess I guess we'll make it like a third of the view. Yeah, I'll make it a third of the view width. Well, it's absolute, so it's not gonna know what to reference, I think. But let's see what happens. It'll be relative to the parent of whatever this is, the first relative parent that comes along. Width 33%, height 50%. Let's see if that even works. If there is like a relative parent for it to reference off of. And then we'll say background. We'll give it a black background just so we can see it in the scene. And we'll go to this view. So I think you guys will be able to see what. Yeah, so we'll go to this view. And it looks like, yeah, it looks like I'm not seeing anything popping up on the screen. Let's look at I'm looking at I'm looking at the developer tools and I'm seeing it in I am seeing it in the actual DOM. It's just not rendering on top of. Looks like it might be rendering behind the canvas or yeah, I don't know where this element is. It's in the DOM. Like you can see. Oh, yeah, it's in the DOM. Maybe because it has no content. Well, maybe I'll make the position fixed instead of absolute. Oh, well, maybe I have to anchor it to the top. And then we'll probably want it on like the right side. I actually kind of want it on the left side for some reason. Yes, there we go. Okay, cool. Um, Background color doesn't really have to be black. We can leave it like transparent, but we'll make it a flex element. Or I guess we'll have to put a flex element. Actually, can we just say display flex? Flex direction, column, flex wrap, no wrap. I'm so used to using Tailwind that I feel like I almost don't have the actual CSS properties or attributes like at the tip of my tongue. And then let's give that some padding actually. Let's give that like one rem of padding. Nice. That looks good. Okay. Um, that's good. And then we'll do like little divs. class input container. We'll do little like input container divs so that we could put like a label. We'll do like a span and then just say, well, what are we working with on the cup? We're working on the cup height. And these might end up being sliders. I think that would make a lot more sense. We say equals, can you say that? Like, is that, no. We're gonna have to go to Safari and check the documentation, the Mozilla documentation on inputs. Mozilla slider input. Input type equals range. There we go. That makes sense. Input type equals range, and then cool. And then we're gonna have to print the value like next to it too. So we'll also put that inside the input container and say we'll do a span, and then we can do cup height input, and then we'll call it that, and then we'll cup height input equals ref. Set it to 0. Cup height, I feel like it should be millimeters, just for like, and then instead of having to like update the cup height on every like at input, we should do, what is it called? It's called a, no, it's not called a ref. Let's go back to the view documentation. Usually I don't. Usually I would use the at input function. Oh, v model, that's it. Yeah, usually I do not use v models. I would catch the input function and then update the input manually. But I guess we'll just keep it simple here and say cup input height millimeters. Always good to put any variable that carries a value should always contain the unit, is something that I'm very particular about when I write code. Okay. Okay, that's not updating. Does not exist on type. Is it not a ref that we want? Let me go back to the view docs. Yeah, so that should be working. I don't know what's going on with that. Is this just not spelled right or something? Oh yeah. Oops. Okay. Okay, cool. Yeah, now it's working. We're getting 0 to 100. Um, we're gonna have to define ranges because the ranges will change as the constraints change. So well, I guess we should define like we should anchor one. We should have one constraint be unanchored because it's really annoying when you slide one thing and then another constraint changes and then that prevents you from like setting any other constraints. I've been in that situation with various softwares and it kind of sucks. So I don't know, maybe it should just give you a big fat warning instead of like instead of physically constraining you from moving the sliders and values where you want them. But let's style this class just so it looks a little bit better than it does right now. Dot input container, and then we'll just say display flex, flex direction row, line items, center. Gap is it just straight gap? Yeah, it's a shorthand property. But we'll just say gap half a rem. Okay, cool. That looks great. And then we'll just we'll just repeat that for all the other inputs that we need, which are we need the cup height, cup diameter, input millimeters, and then we need the wall thickness. And that should be enough to define the cup. Then I guess we kind of do either need to watch all these values or like we need to know when to update the we need to know when to actually update the mesh. So we kind of do actually have to either use an input. I guess we'll just catch the input event instead of using a watcher. Actually, no, I think we should use a watcher with the V model because if this value changes somewhere else programmatically, then we're also going to want to update the mesh. But we also don't want to get caught in like a race condition or like a recursive state where if one thing updates the mesh, it'll draw the mesh, and then the mesh will just the draw mesh function might update um, update another one of the refs, right? So that the slider stays up to date with like a constraint or something. So I think will use the inputs and just say add input update mesh. I feel like that's the simplest way to do it. And then to change the model as well. And add those const cup diameter input millimeters equals ref 0. No, cup wall thickness input millimeters equals ref 0. And then cool. These are all independent values now. And then let's implement that update mesh function. So that's a really bad name for it. We'll call it redraw cup. First, we'll convert all of the values. So we'll create a type const cup params cup parameters equals height And then let's go to units. Do we have feet to meters, inches to meters? No. Let's do converts millimeters to meters. I guess it's not super necessary, but there's no need to not reuse the code that does this. Okay. Let's import that. Um, okay, cool. Import millimeters to meters, and then down here in our redraw cup, we can go height, um, cup height input millimeters. We'll have to pass that to the millimeters to meters function. Good. Getting a little bit tired. Damn. Um, height. What do we? What else we have? The cup diameter, outer diameter, cup diameter input millimeters. Oh, oops. We need to use the dot value here because these are not numbers. They're refs. And then we have the wall thickness. We also have the bottom thickness too. The sidewall thickness. Cup wall thickness, input millimeters, dot value, and then we do have to do the bottom thickness. Just back create that. Just copy this. Cup bottom thickness, input millimeters, dot value. Cool. And then we'll do the well. When we create this cup mesh, I think we want to have like we want to be able to destroy the old mesh, right? So maybe we'll. This is probably not the best way to do it. We can just do scene dot find mesh, like get mesh by name, I think. Yeah, get mesh by. Is this the name or the ID? It's the name. So get mesh by name. Um, should probably just hold a reference to this mesh, but dot. Is it destroy or no? Dot clean. Remove? No. What is the what is the method in Babylon for destroying a mesh? Destroy, remove. I'm just thinking of synonyms now. Destroy, remove, trash, garbage. No. All right, I'm gonna have to look this up. It's dispose. Close. Dot dispose. Okay. And then we'll redraw it. New cup equals draw cup params. And then does that like will that just oops. I think that will just like put the cup in the scene, but let's see what happens. Let's create that bottom wall thickness param. And let's create the input for it. Okay, this is not update mesh, it's redraw mesh now, or redraw cup. Okay, well we'll change that later to just be a general mesh update or general mug update. And then let's add an input for the bottom thickness. Okay. Let's see what happens here. Oh, there we go. Change this to 100 cup diameter to, oh, there we go. Yeah, there's definitely some weirdness going on with the meshes. I think we have to dispose of the meshes after we do the CSG thing. Will this will this destroy the old meshes? No, so we have to clean up those old meshes. So const outer cup, or sorry, not const, just outer cup dot dispose, inner cup dot dispose. Let's see what happens after we dispose the meshes, if that kind of helps things along. Yeah, it does. So the cup is now 100. I don't know why the diameter, like it's just picking the, I think it's picking a default diameter of 1 and we pass it 0. So maybe if I try, sorry. Maybe if I try setting the diameter first. No, that doesn't really work better. So we definitely, like, you can't just have these slammed to 0 and then be sliding them around. We need a better way to catch. I mean, is this throwing? Yeah, so it's just a ton of errors in the dev console because of the invalid dimensions that we're giving these early meshes. So right, and then these. So I guess this redraw cup function isn't really necessary. We should just be doing the create mug. So we'll just put this, we'll get rid of redraw cup, and then we'll just put all of this in create mug. Right, we're there. Oh, right. Redraw mug. We'll do a redraw mug function. And then that will just use the variables. The redraw mug will dispose of all the old meshes. Yeah, and then it will create. It should just dispose the transform node, I think. Get transform node by name. Mug parent, and then we'll just dispose the whole thing. And I think we should be able to. Will this recurse into and destroy the meshes? I don't know, but we'll see. We'll see if it does. And then new cup equals draw cup. That's okay. But then part of like the no, this should not be. And then for now, we'll just comment these out and we'll build them out as needed. Const cup equals draw cup. Mug parent dot add child's cup. And then I think part of the create mug function should be running the zero checks. Actually, I think those should be part of like the individual cup functions. So is bottom thickness valid greater than, and so we'll just do params dot bottom thickness is greater than 0 and same with this. We'll do params dot sidewall thickness is greater than 0. Has to be greater than 0. And then if we run these, we'll just get the errors that the wait, redraw cup is not a function. Oh, right. We have to do redraw mug. And then we should just be getting a bunch of errors that say the bottom thickness isn't valid. So instead of trying to draw the mesh and getting this all malformed thing, now we should be getting an actual mesh that works. Okay, cool. The only thing is that we're not getting the right wall thickness. So we can increase the diameter, that's working. Looks like we can increase the height, that's working. We do want to offset by half the height, so we'll just right away we'll go ahead and fix that because it looks bad when the floor is like in the middle. I guess the transform node. Yeah, I think we want the origin. I think we still want the origin of the transform node to be right there in the middle. So the cup, when we draw the cup and we add the child, we should say cup dot position dot y equals cup params dot height divided by 2, and then that should lift it up. Let's say bottom thickness 15 millimeters, wall thickness 17 millimeters, cup diameter 60 millimeters, cup height. Yeah, so now that looks good. This is working. The wall thickness thing is not. Like, it looks like when the wall thickness is, oh, yeah, there's something, when the wall thickness is like half, like exceeding half of the cup diameter, we're getting some weirdness, which is leading me to believe that there's something up with the CSG situation that isn't quite right. Like, what is that? Why is oh, I see. We need to offset the inner cup up. Um, so we'll do like the inner cup needs to be offset up by the wall thickness. I actually think that we should make the wall thickness, like we should make the inner cup the same as the height. That way we know that it's always going to cut. And instead of making it smaller, it should be offset up by the inner height, or sorry, by the bottom thickness. So inner cup dot position dot y, we just say plus equals, or honestly we should just say equals because we know they should initialize at 0 equals params dot bottom thickness, and then now we should be getting more of what we expect with the CSG, I think. So say the bottom thickness is 15, the wall thickness is also 15. Make the cup diameter 60, and then yeah, there we go. So now we're getting what we expect to be getting. We're getting a cup. That looks pretty good. I think we're good on the cup. How are we on time? Where are we on time? Oh my God, we only got 40 minutes left. We're gonna have to really speed things up, or we'll go over, which has happened every time, which is okay. I don't this whole like camera calling distance thing is really bugging me. I'm gonna, even though we're really crunched for time, I'm gonna try and fix it. I'm just looking up Babylon camera calling distance on DuckDuckGo. Right, the clipping plane, the max Z. Okay. Um, I think that's the min and max. I think that's gonna be the min and max Z on the camera. Let's see if that's already set. Min Z. No, it's not. In the scene setup, when we create the camera, like we want to get right up close to this cup. So like we want to be able to get maybe like, I mean, within like 10 centimeters of it. So 0.1. We'll try and get within, like 5 centimeters of it. I think that's okay. Yeah, that's better. Bottom thickness 11, wall thickness, cup diameter 70, height 100. There we go. Yeah, it's looking good. It's looking very good. These slider ranges could be a lot better. How do we set the... Let's go back to the Mozilla documentation for the input type. Value list max and min. Okay. Okay. So we'll give it a max and min. Well, the min should be 0. I think that's the default. But we'll set it just in case. And then oops, and then max. I guess we'll make this a ref because why not? Same with this actually. We'll make these all refs because maybe we'll want to like programmatically change them. Cup height input min millimeters. Cup height input max millimeters. And then this is where Copilot would be really nice because it would pick up on what we're trying to do pretty easily, but we're going to be purists about this. This is probably why we're not going to hit the 3-hour target. This is taking like a minute just to like do this basic boilerplate stuff. Or not really boilerplate, but just like very repetitive copy pasting stuff. I guess it's good not to use Copilot though, because then maybe you'll appreciate it a little bit more. So the min will be 0, const height, cup height, input max millimeters. I think maybe like 400, I don't know. Just working with what kind of made sense when we were catting things out. The diameter, the minimum diameter should probably not be 0. It should probably be like 10. And then cup diameter input max. Would it make sense if we made it? No. Kind of want to set this to 1,000. Like, just set everything to like a meter if it's like relatively unbounded. The wall thickness minimum, yeah, it's technically 0, but also no, because 0 doesn't make sense, so we'll set it to 1. Input max. And then again, this is, I guess we'll initialize this to like half of the, to the constraint, which is that it has to be less than half of the diameter. So cup diameter. Also, these mins and maxes are not making sense with the actual initial values. Like if the initial value, if the initial value is less than the minimum, then weird things will happen. And then this should be the diameter. Cup diameter input millimeters divided by 2. And then the bottom thickness should be greater than the height, but cup bottom thickness, the minimum. Again, as a bottom thickness of 0. I mean, I guess it could make sense if you don't want a bottom and you want it to be like an unusable cup, but in this case we'll make it 1 just because we're running out of time and we can't get into the nitty-gritties of usability, I don't think. Cup bottom thickness input max. Maximum bottom thickness is going to be the height. But if we set the max to 0, that's not going to make sense. So we'll use the height maximum, and then yeah, like when the constraints start to like affect each other in real time, I think that as I said before, I do not like when that happens. We should probably just initialize these to like good reasonable values based on the mug that we built in AutoCAD. So I think the one that we built in AutoCAD was like 120 millimeters tall. It actually wasn't a good mug though, remember? Because like it wasn't usable. So we can just like think about, well, yeah, it actually, okay, so yeah, 120 millimeters is like a good initial height. Um, and then yeah, and then A good initial diameter for a mug. What did we say? 60 was nice. Yeah. So we'll do 60. And then a good initial wall thickness was like 4 millimeters, right? So we'll do that. And then a good initial bottom thickness was the same as the wall thickness. So we'll just initialize it to that same value. And then also, yeah, in the mounter, when we mount it, we need to redraw the mug. Okay, cool. So that's like our initial default, and then we can increase the height, slam the height. We can make it wider. We can make it taller. We can make the walls thicker. Why is it 30? Where did that come from? Oh, because we set the max to half of the cup diameter, but that's not dynamic. So let's put a watcher on the cup diameter and then update the wall thickness, because I think that is one of the constraints where it's like okay to where it's okay to constrain it based on another value, because you wouldn't really want to change the wall thickness above the cup diameter. I think it would make sense to just say like first increase the diameter and then you can go ahead and change the wall thickness. I'm just looking at the view documentation for watchers to make sure I get this right. So you just pass it. Yeah, you just pass it the ref, and then there's an async function with the new and the old. Okay. So we're going to want to watch the cup diameter input millimeters, and then we pass it a callback function, or not really a callback function, but just an async function that is the old. Is it new and old or old and new? Is it new and old? That kind of makes sense. We don't really care about the old. And we'll pass it this little anonymous function. We do need to import watch from view. Okay, and then we'll say cup wall thickness, the input maximum, right? Yeah, the input maximum is going to be half of the new value. Okay. Let's see. Let's see how this looks. So when we initialize it, we get that default value. Yeah, so the wall thickness is properly constrained here because, oh, it looks like there's some clipping stuff going on, like, or it's just the CSG situation gets completely messed up. Let's add a little, like a quick little, just a quick little fix for that. We can just say, um, if params dot sidewall thickness equals the is equivalent to the params dot outer diameter divided by 2, then we can just go ahead and return that outer cup, and we don't need to run the CSG. Let's see if that actually fixes the situation with the clipping thing or the bad CSG. So we'll slam the wall thickness, and yeah, that fixed it, because once we hit that point, then it no longer even runs the CSG. Cool. And then when we increase the diameter, we can see that the slider changes, and it's working nicely. Okay, that looks good. It looks like we have the cup. Looks like we've got the cup down, which is like the most basic part, I guess. Oh, and then when the bottom thickness, we need to update the bottom thickness based on the height as well. It also looks like there's no light pointing down into the cup, so we just get like a completely black bottom. We should probably fix that too. Um, let's see. In the setup, we're creating a hemispherical light. Huh. So the hemispherical light is pointing directly up. That should kind of be working. I'm not sure why the bottom is completely black, but that's okay for now. When the height changes, we need to add a watcher for the height. We need to watch the height. So cup height input millimeters. Because when the height changes, um, we need to make sure to not allow that bottom thickness to exceed the height. So cup bottom thickness input max millimeters dot value is going to end up being the cup is going to end up being the new height. Let's see what that does. So let's increase the height a little bit, and let's increase the bottom thickness. Yeah, so that's good. We could also avoid the whole CSG thing by checking if the bottom thickness is the same, but it looks like it's working without having to run that check, so we're not going to do it. What is up with that light? What is up with that bottom material? Just be having like no light bouncing off of it. It's so weird. Maybe if we add another hemispherical light in the other direction, we'll do light 2. Now everything is just like bright, and you can't even really. These watchers as well, we can run them. I think there's an option to run them like immediately. Immediate true, and then those will just run as the values are defined, and that will make sure that they always initialize in the state that we want them to, without having to, like, these kinds of like init values, there's probably something wrong. The cup bottom thickness, yeah, like this shouldn't be the input height max, it should be the actual input height as it stands. So instead of having to like worry about any of those, if we just set immediate to true. But yeah, we can't, the whole hemispherical light situation is bad because it's just turning everything straight white. We might explore the lights later, or add a light attached to the camera if we have time, and then that way it'll be like it'll be like wearing a headlight when you're walking around the cup. Okay, let's check time. Where are we on time? We have 20 minutes left. Okay. So we have all the cut parameters down. Let's move on to the handles. Or no, let's move on to the brackets. So the end half length, the draft angle, the extension length, the handle offset distance, and the thickness. That's 1, 2, 3, 4, 5 things. I'm really tempted to turn on Copilot, but I won't. So what were the 5 things again? Let's copy this in. The end half angle. Oh, the end half length. Right. So the end width. I think width is probably like the word that would be most familiar if you were like designing this. So bracket end width. And then that probably won't be the half width, it'll be the whole width. Bracket end width input millimeters. Input min millimeters. Input max millimeters. Okay. Then rinse and repeat. The draft angle. Oh, right. And we had to add that other one, which was the offset, the cutoff distance. Bracket draft angle input degrees. Input min degrees. Input max degrees. Input degrees. Okay. And then we have the extension length. I feel like that should go here. Bracket length, bracket extension. We'll just call it bracket extension. Bracket extension input millimeters, bracket extension input minimum millimeters, bracket extension input maximum millimeters. Okay, and then we have the handle offset distance, right? That should definitely be at the end. Handle offset bracket. It's not really a bracket thing, so I mean, it's okay. I'll leave the bracket in front of it. Offset min millimeters, offset max millimeters, and then we'll throw that into the span, and then finally, actually, this is not final because we're gonna have to do the offset thing. We're gonna have to do the cutoff thing, but bracket thickness, bracket thickness, input millimeters, bracket thickness, input minimum millimeters, bracket thickness, input maximum millimeters. This is probably so boring to watch because it's extremely boring to actually do. But this is the reality when you're not using AI. And then finally we have that like the cutoff thing. So bracket cutoff distance. Bracket, we'll call it the tangent. We'll call it the tangent cutoff distance. Bracket cutoff input millimeters. Um, Bracket cutoff input minimum millimeters. Bracket cutoff input maximum millimeters. And then, should we turn on Copilot? I'm really, really tempted to, but I said no AI. I feel like I have to stick to it. Um, let's just put like, let's put spaces between this so it's easier to keep track of who with who. Const. Then what was the order that we did this in? We did end width, extension, draft angle, thickness, cutoff, and handle. So bracket, end width, input, millimeters equals ref 0. Well, let's give these sensible defaults. Bracket, end width, right? So if the diameter, the initial diameter is 60, we'll make this like 35, 30. Yeah, I'll make this 35. And then const bracket end width minimum. We'll just make these 0, but then we'll probably have to put watchers on it with it that run immediately. Bracket end width input maximum. And then again, this is going to be based on the diameter. But that, the draft angle is going to affect that. So what do we do again? We did the extension and the draft angle. I think we did like a, oh, how far did we extend it? Like maybe 40 millimeters. It's just, are these all misspelled? Yeah, they are. Okay. And then for the, should I just turn on Copilot? No, it's too late. I'm already way too deep into doing this without AI. Or maybe we'll make it like 100 degrees. Bracket draft angle input minimum. The minimum is always going to be 90 degrees, right? Yeah. And then the maximum, I think, well, yeah, the maximum is going to depend on the extension distance, but we'll make it like 180 just because that's theoretically the maximum if the cup had an infinite diameter. And then we have the draft angle, the handle thickness. No, this is the bracket thickness. Bracket, the thickness, the cutoff, and then the handle offset. Bracket thickness. I think we said it was like 8, like, or 6 millimeters or something. That made sense. Bracket cutoff. And again, like, there's some cutoff math that we haven't even fully like explored. And then that was the What was it? The handle diameter? No, the handle offset. And that should probably be like, I mean, if the bracket extension is 40, this should probably be like 30, and then we'll make the handle like 8 millimeters or something. Okay, and then let's just, before we do the min and max, let's just grind out all of the other handle parameters. The handle parameters are height and diameter. Wow, there's a lot of parameters. If it didn't feel like many for each of the components, but once you start adding them all up, there's a lot of parameters. So we have the handle diameter. Handle diameter input millimeters. Handle diameter input minimum millimeters. Handle diameter input maximum millimeters. And then we have the handle height, or the handle length. Handle length input millimeters. Wait, also this should say degrees. The draft angle, bracket draft angle degrees. Okay. Handle length input millimeters. Better not say handle height in the type, does it? Oh my god, it does. Why would it say that? This should totally be height, right? Yeah. Just like from a design standpoint, I think it should be height. Or sorry, length. Handle length input minimum millimeters, handle length input maximum millimeters, handle length input millimeters, and then now we just have the assembly parameters. Let me just add those though. Whoa. I'm like losing my ability to type. Handle diameter input millimeters. I think we said it was like 8 millimeters was cool. Const handle length input millimeters. And then we kind of want it to be like a little bit under the total height, which was that the height was 120. We want this to probably be like 100. I don't know. Well, we want like a 5 millimeter gap maybe. So we should set this to like, actually no, I think a 10 millimeter gap on each side is good. So yeah, 100 is good. And then we have the assembly parameters, which are the bottom bracket offset, the bracket gap, and the handle bottom bracket offset. Right. So there's three of them. Bottom bracket offset. Bottom bracket offset input millimeters. Bottom bracket offset input min millimeters. Bottom bracket input max millimeters. This is so crazy. Doing this without Copilot is insane. It's just dumb. It's just a waste of time. No, bracket gap, right? Bracket gap input millimeters. Bracket gap input max millimeters. Bracket gap input, well no, that should actually be minimum here. And then this is the bracket gap input millimeters. And then finally, the last input parameter is the, wait, this is the bracket gap. Finally, the last input parameter is the handle bottom bracket offset. And that is going to be kind of want to call this bottom bracket handle offset because I feel like when it starts with a position, like, yeah, it seems more like an assembly parameter than a handle parameter, but whatever. Bottom bracket min offset, bottom bracket handle max offset, and then boom, that's all of the parameters. Const, what were the assembly parameters again? The bottom bracket offset input, the gap, and then the handle offset. Okay, so bottom bracket offset input millimeters equals ref. Well, we want a 10 clearance, so 20 is good. 20 is good here. Const bracket gap input millimeters equals, well, if we're putting 20 and then we want even, it's 120. So 120 minus 40 is 80 minus the thickness, minus twice the thickness, which is going to be 12. So 80 minus 12, 68. Wow, that's, yeah, I mean, that's not enough to put your hand in. Just the same thing we ran into on that other initial design, but we'll tweak these defaults and I'll make them, eventually I'll make these defaults consistent with like a good mug that would be usable. And then this was the bottom bracket handle offset, and that should be handle offset millimeters. So I didn't name that right. You start making mistakes, you start getting sloppy when you're copy pasting things. It's tough. And then, right, we wanted a 10. We wanted this to be, well, yeah, this is going to be 10 because if there's 20 between the bracket and the bottom and then the handle is 10 less, then there should be 10 here. Cool, cool, cool. And then that's all of the things. We just have to define the min maxes for these. The minimum 1, I guess. I mean, it doesn't make sense to have a 0 thickness bracket. Input max, and then again, the maximum is going to be the height divided by 2. So, this is going to need a watcher. Like, a lot of these are going to need watchers, I guess. Yeah, a lot of these are going to need watchers. Wow, this really sucks. The bracket cutoff input, the minimum is going to be, well, this is one of those ones where it can actually be greater than negative because we're going back to CAD. The offset is this line. Going back to that original sketch. Oops. Going back to that original sketch, the offset is this line. And this line can come in either, like, if 0 is at the tangent here, then the line can go left towards the bracket to make this straight facet larger, or it can go right to make the straight facet disappear, or smaller until it disappears. So that totally kills our greater than 0 exception, or exception like global rule. So we should come in here and say, I think we had something that said like all, yeah, all values must be greater than 0. I guess we can just say except the bracket tangent offset. What, I forgot what we even called it. The bracket handle offset. The bracket cutoff offset. Inside the bracket tangent cutoff, whatever that means. So I guess I don't know. I mean, it'll depend. So we'll set it to -10, whatever for now, just to show that it can be negative. But bracket cutoff maximum, and that's going to be the bracket extension, I think. Okay. Oh my God, we have to do min and max on all of these. Constant. Okay, so the minimum bracket handle offset minimum is 0. Actually, no, it's more than 0. It's the handle diameter divided by 2. Or is it? Yeah, it's the handle diameter input millimeters dot value divided by 2. Because otherwise the handle will intersect with the cup. Const bracket handle offset input max millimeters equals ref. Is this not a value? What is this? Oh. Oh. Huh. I guess I don't mind moving this below, even though the okay, well we should rearrange this then just to make it clear to the user that the handle offset is kind of like dependent on the handle diameter, maybe just by putting it below. Just a subtle hint. Const handle diameter input minimum. The minimum is, I think, 1 because the handle would disappear otherwise. And then the max is going to be I think we already looked at this, but it's going to be half the it's going to be yeah, no, it's going to be twice the extension, right? Um bracket handle offset input maximum. The maximum offset is going to be the extension. No, the bracket extension. It's going to be the extension minus the diameter. We can go back and look at the constraints that we came up with earlier. Handle length input minimum. I guess the minimum is going to be the gap, the bracket gap, but for now we'll just say 1. And then there's some circular constraints, so the whole order thing is not really right to say this has to be set first or this has to be set second. They're circular. Handle length input max. And again, from a constructability standpoint, it doesn't really matter, but we'll just say this is the yeah, well, we shouldn't really say it exactly because it's fine to set the length to anything from a constructability standpoint. Bottom bracket offset input min. The minimum for the bottom bracket offset is going to be 0. And then the maximum is going to be the heights. It's going to be the cup height minus twice the bracket thickness, right? And then minus the bracket gap. But again, we're dealing with the circular constraint here between the bracket offset and the bracket gap. Bracket thickness input millimeters dot value times 2. Const bracket gap input min. That's going to be the the minimum is going to be 0 because then the brackets, that's when the brackets will be touching. Max. The max is going to be, oh shit, I realized I was on Fusion the whole time. You guys couldn't see anything I was doing. That's okay. I'll go back and show you what I was doing. I was adding all of these classes. Wait one sec. Okay. So the input, the gap the gap maximum is going to be the height. It's going to be similar to the offset. It's going to be the cup height input minus twice the bracket thickness. And again, that's that circular. It's the same because of that circular dependency between them. And then finally, the bottom bracket handle offset. It's the same circular dependency here. We can actually do more since the other ones are defined already. Since the gap is defined, we can also subtract the gap. But again, you know, this is going to have to be on a watcher that executes immediately. Bottom bracket offset max equals oh, well, I guess the minimum offset is 0 and the maximum. Wait, this is the distance between the bottom of the handle and the bottom of the bracket. So the minimum is 0, actually. And then the maximum is going to be whatever makes sure that the handle is still going through the top bracket. So it's going to be, let's actually go back to Fusion for that. So the offset that we're talking about is the distance between this and this. And so at minimum it's 0, right? Because that's when they're flush. And then maximum is going to be whatever ensures that this doesn't go below the top of the bracket. The top of the handle doesn't go below the top of the top bracket. So in that case, let's think about this. It's going to be, well, we can think about it in terms of the distance between these 2 points, which is going to be the gap plus twice the thickness. The distance remaining of the handle cannot exceed that. So let's just put that in a comment so that like we can come back to it in a sensible way. The distance the distance between the bottom of the bottom bracket and the top of the top bracket must be remaining on the handle when it's offset. that kind of makes sense. I could probably said that a lot better, but we can basically say that the maximum value is the handle height minus um minus the bracket thickness times 2 minus the bracket gap. And again, like these initial values are all going to change with watchers, but it's kind of helpful to just see the math played out when it's initially set, I think. But we'll have to kind of think through them later. Okay, whoa, how many parameters do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 parameters. Wow. That's interesting. And we've blown over the time. I'm gonna have to update this timer so that it can keep going after, but we've for sure blown over the time. Okay. Let's start drawing the brackets. Let's start drawing the brackets here. Redraw mug. Let's go to the draw cup function, the draw brackets. The end half length. Right, so drawing the brackets, I think we're gonna want to draw a polygon in terms of like a mesh construction standpoint. Yeah, we're gonna want to draw a polygon. So let's do that. Let's think about the polygon that we're gonna draw. Go back to Fusion, and then maybe just create a new sketch in the form of the polygon that we're gonna draw. We'll hide all the bodies and stuff. So the parameters that we're working with are the bracket end width. So let's think about our polygon in terms of like a starting point at the tangent. So this line is the bracket extension. So we'll make it like 20. And then we'll start here. So we'll start our point at I'll actually write this down this time. So we'll start our point at we'll think of this in xy because it's just a plane. So we'll start our point at bracket extension. So extension comma 0. And then we'll come up from that point with half of the extension. So the next point after that is going to be the x will be extension, the x coordinate will be extension, and the y coordinate will be the bracket end width divided by 2. So that's going to be this point. So we'll just put that at 8. And then we're going to draw the draft angle up to the cutoff point. So that's going to get a little bit more tricky. The cutoff point is based at the 0. So when the cutoff point is positive, I guess we should go right. Yeah, we should go right when the cutoff is positive. So the next point is going to be, we're going to have to use a little trigonometry here. The next point here that I just put down, the x coordinate is going to be I think I might just pull us into Sketch. It'll probably be a little bit cleaner to like to show this stuff out. Um, we'll do this on a sheet of A2 paper for you guys. Okay, so we have like we have the mug. Let's make it 250 by 250 pixels. And then we have the extension coming out from this tangent point. That's our extension. So this starting point, we'll start the polygon here at extension comma 0. And then we'll come up straight up to the next point on the polygon, which will be extension comma 0 comma end width over 2. And then we have our offset situation, which is where things get tricky. So we can just think of the offset line as like an imaginary line. It's not part of the polygon, right? So we'll make that a dotted line. What did they? Sketch has changed a lot in the past few updates. It's not a fill, right? No, you have to add these extra border. You have to click on this extra little gear and then you can change it. And they got rid of the little up and down arrows, and now you have to use these slider things. But anyways, that's the end of my complaining about Sketch. So this is the imaginary offset line. This distance right here is the offset distance. If that's positive, it's going to be towards this way. And then if it's a negative offset distance, the offset line is going to be inside the mug or inside the cup. But basically we have to figure out this line that starts at extension comma end width over 2 and ends at the offset. And it's going to be based on this internal angle here. So I'll just this is not really that necessary, but at least they make the scissor tool more easily accessible. That was behind like 2 layers of menus on the old version. But okay, so that's going to be our draft angle. So I'll call that theta. Or no, I'll call that draft because it's the same number of characters. Okay, so that's the draft angle. And this is the extension line. The question that we have at hand now is what is this point here? What is this next point on the polygon? I think the best way to compute that point is probably a slope intercept type situation. So we know that the slope of this line, well, we have to come up with an equation for this line. So yeah, we have to come up with an equation for a line and then solve it for this value of y. And if this is 0, then this value of y is going to be the offset distance. So we have to come up with an equation of this line. Um, there's multiple ways that we can define a line. We can define it in slope-intercept form. I think that's going to be the best move because we have the angle and we have this point. So the intercept point, so y equals mx plus b. I'll type this stuff out. So y equals mx plus b. This is we're working with a positive, like we're working with a coordinate plane that's going positive this way and positive up. So the slope is going to be negative. Also, we're starting with a y offset as well. Does that matter though? Yes, it does. It does. I guess we can, well, I guess we can kind of do like our own little coordinate plane for this one particular line calculation where we can say this is like the new coordinate plane. This is the new coordinate plane here. This is now y equals 0. So right, we want xy here. We're going to plug in a new value of y here, and we're going to get x. That's what we're going to do. So we really, we can rearrange this for x because we want the, actually, no, we need to rearrange it for y because we already know the x value. The x value is the offset. So this is actually a good form. And then this y-intercept, we don't actually need this. The y-intercept is end width over 2. So y-intercept, that's the y-intercept, right? And then the slope m. Let's look at well, we have to use, that's where we have to use tan, inverse tan, or just tangent really, because tangent equals opposite over adjacent. Actually, I'll bring that little line back that I did. Or no, tangent, yeah, tangent equals opposite over adjacent. So let me bring back this line. And then this is the draft angle. So we're going to have to actually subtract 90 from the draft angle to get like theta here. And then theta. And then tan theta. Tan theta equals opposite over adjacent. Opposite is going to be the thing that we actually want to solve for. So maybe we don't need the whole line situation. The whole line slope situation. We're trying to solve for this, actually. Let's call this y1. We're trying to solve for y1. We know theta, it's draft minus 90. So tangent theta equals, oh, okay, okay, so tangent theta equals opposite over adjacent. Let's rearrange this. Well, opposite, Adjacent is extension minus offset. Adjacent equals extension minus offset, right? Because this is the extension is from the end of the tangent of the circle to this far point, and then the offset is this distance. So this remaining distance from here to here is going to be the extension minus offset. I'll put that here to make it very clear. This distance here is extension minus offset. This line. So that's opposite, which is this. So opposite equals extension minus offset. Adjacent equals y1. So let's rearrange this in the form of adjacent. So adjacent, or sorry, let's reform this in terms of opposite, which is just, opposite is just going to be tan theta times adjacent. So that's pretty straightforward now. So now we know that opposite equals tan theta minus adjacent, and we know that tan theta equals, we can just start filling these in. We know that theta is draft minus 90. And then we know that adjacent is extension minus offset from this. So this point right here then, the x coordinate is just going to be offset, right? Because this is saying that this is 0 at the edge of the cup. So x coordinate is just offset. And the y coordinate is going to be end width divided by 2 plus this whole situation, this whole opposite, y1. You can just call this y, like we'll just put y1 here. Y1 opposite equals y1. So y1 equals this. So now we have an equation for that next point on the polygon. That's pretty cool. And then I guess we need to figure out if y1 plus extension is, we need to figure out if this will intersect with the circle. So let me look, like, I mean, I guess the easiest way to do it would just be to check if y1 plus end width divided by 2, if this distance right here, if this is going to end up being greater than the radius, then it will never intersect. This line is going to fly past. So I think that will just be an easier way to check. So we'll just say up here, if we'll call it y1. If y1 is greater than cup radius, it won't intersect. But then we have to figure out, right, and then if I think as long as I'm trying to figure out like how we know if we need another point on the polygon. Um, well, I guess we can just go up to the offset and then cut out. No, you can't do that. Actually, let's go back to Fusion to see how we did that. Um, see how we did that with this. Right, so we just went forward until we intersected, and then we cut out the circle. So how do we know how far we need to go forward in order to intersect with the edge? We could just compute the distance. We could do a distance computation between this point here and the edge of the circle based on a straight line perpendicular to the tangent. I think that might be the move. So let's go back to sketch. Right, because what we're trying to do is figure out this situation. So once we have that point, but then how do we know how far to come out this way so that we'll intersect with the circle? Um, how do we get that next point? I think I think we can just use a straight distance equation. I think that's I think that's definitely a thing. Probably some formulas out there that we could look up. I'm just wondering if I could think through this without having to look up any of the formulas. Or just think through it in a more simple, find a more simple geometric solution to this. Um, let's think. The intersection, the line will not intersect with the circle. Well, we already know that we have to keep the draft angle down. We already know that that line will intersect. I mean, if we wanted to brute force it, we could just add, like, if since we're just gonna cut away with a CSG, instead of finding that exact point, which is probably not the move anyways, because we don't want to clip it weirdly with the CSG. Like, we want a good amount of margin for the constructive solid geometry math to be able to just cut away cleanly on an like in the middle of an edge instead of right at the end of a point on a mesh. We might as well just add half of the diameter like to this point. So this point will never exceed, this length will never exceed the radius of the cup. It should never exceed that. And so we can just add the radius, the outer radius of the cup to that point, and then use the CSG to clip off the outer radius or the outer diameter of the cup. So I think we'll just do that. I think that'll be the easiest, cleanest, and like it'll give us the result that we want without having to think about this any longer. So in that case, the y coordinate is going to be this situation that's y1 plus end width over 2. The y coordinate will stay the same. I guess we also do need to decide though, like, is this gonna, we actually do need to figure out if it's gonna intersect, because if it's right, like I'll show an example here. I'll show a case here. If the trapezoid comes right up to the edge like here. Oh, right. There's also a situation with this. Well, yeah, if it comes right up to the edge here, then if we continue this by half the diameter, which will be something like this maybe, like this it won't clip, or the CSG won't cut away this little portion here, this little like triangle arc thing. So we do need to know, we either need to know if this is going to intersect, or we could modify this mesh so that it extends back. So instead of just clipping a circle off of the trapezoid, it clips like, we'll modify this to just go all the way back like this. Um, Something like that might be the simplest solution. I do feel like there's probably a more elegant way to compute that kind of an intersection, but I'm trying to think like what another method might be to compute the minimum radius of this circle to intersect. And if that minimum radius is greater than um the actual radius of the outer cup, then we know that there'll be a flat facet. And if it's less, then we know that the ray will fly past. That could be another way to do it. Um, just in the interest of getting this done, I kind of just want to do it in the most, just do it in a very straightforward CSG way where we'll extend this circle, the mesh that we use to cut the trapezoid, to cut the bracket, will just end up looking something more like this, where it's like it goes all the way back as a rectangle by at least the diameter. And then that way we know for sure it'll just chop anything off that's hanging over the hanging past the end. So this is getting pretty crazy. I don't know why I thought I could finish this in 3 hours, but let's do this. I'll take a screenshot of this. And then probably open it up. Okay, I've got a screenshot of that open on my other screen. Let's go back into VS Code and actually like implement this. So the draw bracket function, getting a little bit crazy. We need more than just the bracket parameters now, because we need the cup diameter as well. Without that, we won't be able to cut. We won't know how to cut the bracket. Okay. So I guess we'll start with the first. Well, let's draw the polygon. Let's figure out the polygon situation for Babylon. I think we'll just create. Let's go to the API. Extrude, I think. I think there's like an extrude. If we're gonna extrude a polygon, then we're gonna need to download ear cut, which I think we already have. Yeah, ear cut. Oh, you can add holes. That's kind of cool. So build vertex data. Yeah, I think this is the move. Look at this. Let's look at this code example in the playground. So you create corners. Yeah, new vector twos. Polygon mesh builder. You just pass it. Oh, you just pass it the corners, and then wait, what? Polypath 2. Oh, okay. Okay, so you gotta build the polygon and then need to somehow extrude it. Where is it being extruded? Oh, it's not a simple extrude thing. You have to add. I think these, I think all of the other points are being added. Huh. That might not be the move. I'm pretty sure there's an easier way in Babylon to do this. Let me duck duck go it. Mesh builder dot extrude shape. What are the options? The path. Oh, so you just give it a path and then you give it. Where's the thickness though? The shape. How are you like? How do you define the thickness? Is what I'm trying to figure out. Let's see. Oh, it's you extrude it along a path. So this is right. So you have the shape and then you have the path. So the thickness will just be the height, the length of that path. That makes sense. Okay, that's cool. Let's do that. Let's do that. So the shape profile in the XY plane, that's what we'll do, and then we'll extrude it on a YZ along a YZ path. But that's not really what we want in terms of coordinates because our Y is up. So we want to extrude it along. Yeah, actually, I think we do want to extrude it along a YZ path. Yes, we do. We do. Okay. So let's go back. Let's go back into Fusion. Or sorry, let's go back into Babylon and actually make this happen. So const um, bracket outline path equals, well, now we have to define all the points. Um, so an XY. So the first X starting point is going to be extension comma 0. So params dot extension length comma 0, and then this is all the Z coordinates are going to be, no, we actually want to do this on the XZ plane. Yeah, we want to do this on the XZ plane because if we go back to this, we'll see that we have X and Z here. So we want to do it on the XZ plane. Okay. So the second point is going to be extension comma end width 0. Babylon dot vector 3 params dot extension length comma 0 for the Y, and then the end width divided by 2. Oh, it's the end half length. Okay, cool. That's what we wanted. And then the third point is where we get into the whole offset, the whole theta thing. So new Babylon dot vector 3. We're going to go into params dot What's the offset? Did we not define that yet? Um, the draft angle and the draft offset. I guess we'll call it the Sorry, I have to take a quick tiny break. Okay. What were we calling this in the actual thing? We were calling it the tangent cutoff. That's what we were calling it. Tangent cutoff number. Okay. And this must be, I mean, I guess we don't want to get too deep into this again, but it must be, has to be less than the diameter, right? Yeah, it has to be less than the cup parameter divided by 2. Or sorry, greater than negative. It has to be greater than has to be greater than the negative cup diameter divided by 2, because this value can be negative. And then it has to be greater than the cup diameter 2, and it has to be less than the end extension length. Sorry, y'all. I've been at this. I mean, I think I've been at this for 4 or more hours at this point, so um I do have to take a tiny little like break just to catch up on some messages I got. Okay, I'm back. The tangent cut off. I'm gonna have to stop, guys. It's already 7. I'm gonna have to stop at I'm gonna have to stop in 30 minutes, and I don't actually no, I'm gonna have to stop in 20 minutes, and I don't think that I'll be able to finish this, but this will be part 1. I'll just rename the stream to part 1, and then that will be that. Okay, and I wasn't even on the right window, so that's unfortunate. But I'm in VS Code, and I'm working on the draw bracket function. So we're working on the tricky point with the tangent situation. So we have the first 2 points, and then we have the x coordinate of the tangent point is just gonna be the offset, or sorry, the cutoff. I've been calling it offset, and it's actually cutoff. It's gonna be the tangent cutoff, and the y coordinate is gonna be this tricky thing. It's gonna be the half end width plus um, math dot tangent of the draft angle minus pi over 2 minus 90 degrees times the extension minus the offset. Pretty crazy. Pretty crazy little point there, and that's supposed to be the z coordinate, so we have to have a 0 between that. Okay. Okay. And then we get into the whole situation where we're just kind of like throwing these points out there and then just cutting off whatever we don't need with the CSG. So this situation, we want the same y coordinate. So I think I'll pre-compute that because we're gonna reuse it. Really bad variable name here, guys. I'm out in 20 minutes. I do not have time to be coming up with great variable names. Okay, so that's y1, and then we want to go back. We want to go back from the offset by half, at least half the diameter of the cup. So the x is going to be offset params dot tangent cutoff minus the cup outer diameter divided by 2. And then y is going to be 0, and z is going to be x1 again, which z is really y in this coordinate plane that we're working on. And then we're going to dive down and basically mirror that whole thing. So mirroring it will be very easy. We can just we just put negatives on everything. So babylon.vector3, it's going to be this point, but negative. But the y coordinates are negative and the x coordinates are the same. And the next point is going to be same as this one. X coordinate same, y coordinate negative. And then again with this point, same situation. X coordinate same, y coordinate negative. And then we'll meet back up. So we have to, then we'll just come back to that point. And that's going to be, that's going to form a closed polygon. And then const bracket extrude path equals, we just want to go up y. So we'll start at 0, 0, 0. And then we'll go up in the y direction. by the thickness. So params dot thickness. There we go. And then z is 0. And then we do that whole extrude thing. Let me quickly go back to the documentation. We do babylon.meshbuilder.extrude shape, and we hit it shape path. Okay, cool. Const extruded bracket equals babylon.meshbuilder.extrude shape. Why is there an extrude polygon? Why didn't I just use that? But whatever. Oh, right. All right. I think we already looked at that. I didn't want to create a polygon before. Okay, so this is going to be bracket extruded. This is going to be temporary. So I guess we'll put temp behind it because we still need to run a CSG on it. And then options. So shape, yeah. Shape is going to be the bracket outline path. The path is going to be the bracket extrude path. And the side orientation is going to be Babylon dot. Isn't there a side orientation thing, or it's Babylon dot mesh dot outside? Babylon dot mesh dot outside, or no, double side? We'll just do double side for now, whatever. And then I think that should be added, like that should exist in the scene. Let me. I think in this case we'll just return the extruded bracket. And we're not going to do the whole CSG thing because this is going to be the last thing I'll do on this leg of the run. And then we'll do we'll delete that old bracket. This is going to be, there should probably be like a bracket parent, whatever, or, oh no, we're deleting the whole thing. So const bracket params equals, what are you working with? End half length. I'm too lazy to just even type all that in. And the bracket is the one that has the most parameters. Okay, working with the end half length. Millimeters to meters. Bracket. End width, input millimeters divided by 2. Draft angle. Oh my god, we're gonna have to convert to radians here. Converts degrees to radians. Export function degrees to radians. Degrees number. There's 180 degrees in 1 radian. and there's 1 radian in 180 degrees. So, um, I'm doing a little scientific notation on this shit. So 1 degree equals, sorry, one rad equals 180 degrees. So 1 degree equals a radian over 180. So return, fuck me. Nah, it can't be that fucking simple. That doesn't make any sense. Kind of does though. Huh. Oh, we have to multiply by pi. That's what I was like missing. I was like, where's pi in this situation? Because one radian does not equal 180 degrees. It's a pi radian equals 180 degrees. Oh, okay. Then we have to import that whole situation, but that degrees to radians. Bracket draft angle input degrees dot value. This is killing me. Tangent cutoff. This is going to be in millimeters as well. Bracket cutoff input millimeters dot value. Extension length. Bracket handle offset input millimeters dot value. I think on this next leg I'm gonna have to use Copilot or some. I don't know, because this just sucks. I feel like it sucks not because like I don't enjoy writing code, but it sucks because it just feels like there's no reason to be slogging through all this, like no good reason, you know. And I feel like no AI is like a little bit different from Copilot. Like I'm not gonna use an agent. So maybe I should have said no agents. Maybe I should have been more careful with my words when I was setting up the stipulations for this particular marathon. Okay, I've got the bracket params in. Um, create mug, cup params, bracket params. Okay. And then what is this create mug function? It's returning the mug parent, but there's no reason for that, right? Okay. Const bracket bottom equals draw bracket params cup outer um cup params dot outer diameter. Okay, cool. And then we can add that to the mug parent. Mug parent dot add child bracket bottom, and then we have to offset it by x. Actually, I don't know if we do because we're already drawing it. Yeah, we do. We have to offset it by x by the half the diameter. So bracket bottom dot position dot x equals cup params dot outer diameter divided by 2. Let's see what happens. Let's see what happens. I'm not seeing the bracket. It looks all messed up. It looks all just like it looks just two lines. What's going on here? What is going on here? This is bad. This is discouraging. There must be something wrong with our points because I think we're getting the right, like, oh. Yeah, because you built it in the XZ plane, right? The tangent, the cutoff is making it go up. I'm not sure why. That might be a clue. It could be an issue. Bracket extension is not even. Bracket thickness. Okay, so that's kind of going the right way. I think there might be an issue with the way that we're drawing the bracket here. Let's make sure that we're in the right plane. 0, 0, 0, 0, 0, 0, 0. Yup. Bracket extrude path. X, Y. Yup. Path is in the Y direction. X, X, Z. Yeah, we're in the XZ plane. That's correct. Let me just do something really simple and just get rid of these, and then that should just be a rectangle. Okay, so it's not just a rectangle. There's probably a ton of errors here. Bottom thickness. Huh. Okay. So, oh, you guys can't even see this. This is the situation I'm dealing with here. When I just had it the way that it originally was when I just wrote it, this is what's going on with the bracket. It's like just these two like strips. And then if I change the when I change the bracket draft angle, nothing happens. When I change the bracket extension is just like broken. It's not even moving. When I change the bracket end width, for some reason these strips are getting closer together. It makes me think that I'm drawing it on the wrong plane. When I change the bracket thickness, the strips are also changing, like strips are getting like thicker or wider. So it makes me think that there's definitely some situation going on where I'm in the wrong plane. But I'm gonna have to cut it off there, guys. Um, it was a good first run. This is gonna be renamed part one, and I'll be back tomorrow or later tonight, hopefully, to finish this off. See you guys later.